Does it disprove the ether? Does it prove heliocentrism? Who's the baby daddy? We're going to get to the bottom of it today. I'm going to make my case for it throughout this presentation. And as we go forward, we'll take breaks for like little Q&A sections, but please don't interrupt while I'm going through the slides. But the last couple of times I presented here, everyone was super chill about it, so I think we can keep it open and move forward pretty easily. So we'll go ahead and start it out. All right, so starting off, we're going to build upon the scientific method and what it is, just to start a foundation for what is an experiment, how to differentiate between an experiment, a demonstration, etc. So the scientific method, what it is and what it isn't, it's not magic, and it's not a mathematical formula. It's a process of observations, and you do experiments, and the goal is to reach a theory to explain a phenomenon in an accurate way that represents reality the best you can. And the big point of the scientific method, I think, is the repeatability of the experiments. Is your experiment repeatable? Can other people reproduce the effects and all that? So some definitions moving forward. A hypothesis is a statement that's made by a researcher that is a working assumption that is to be tested and proven. It is something that is considered true for the purpose of the investigation. Example, the earth is round. Theory, general principles drawn from facts that explain observations that can be used to predict new events. An example would be Newton's theory of gravitation or Einstein's theory of relativity, based on a falsifiable hypothesis of phenomenon that we observe. And falsifiable and null hypotheses. So to falsify your hypothesis, your hypothesis that is generated must be able to be tested and is either accepted or rejected. So based on the outcomes of your experiment, and how it aligns with your hypothesis, it's either going to affirm it or nullify it. It's going to present positive evidence for it or evidence against it, right? It's basically how you go forward with it. So the process of the scientific method would be step one, you make your observation of a natural phenomenon or an event, whatever, or what have you. Step two, define the problem. So ask questions about the event, come up with ways to define a hypothesis for an experiment and all that. Step three, you form your hypothesis based on, everything that you were going over earlier in regards to the event and or phenomenon. Step four, conduct your experiment to test your hypothesis. Step five, derive a theory based on the outcome of the experiment and how it aligns with your hypothesis, and and how you can build a new hypothesis based on the experimental evidence, etc. Right? So it's all based on what the outcome of the experiment is, essentially, and its repeatability. So here for the final step, we have replication, and this is in regards to, can other people reproduce your work, which is a huge factor in the scientific method, because if you're the only one that can do a certain special experiment that proves it, then you got a problem, right? Other people should be able to reproduce it under the same conditions. So step one, following the same process, we're going to analyze the heliocentric and geocentric models in the Michelson Morley experiment. So step one, observation. Throughout the course of a year, the stars throughout the night sky change every 6 months. Is the Earth in motion with the celestial bodies, or is the Earth at rest with respect to the celestial bodies? So we have two possible answers for our observation here. So defining the problem. Is the sky moving, or are we moving with the sky? From our terrestrial perspective, and using models based solely on observations, i.e. calculative models based on reoccurring cycles, there's no way to differentiate between the correctness of the axioms of heliocentrism or the axioms of geocentrism with respect to the rotation of the sky. Meaning, are we in motion, or is the sky in motion? Are we at rest? What's going on here? So there's the problem. So we're going to get into some visuals of the heliocentric and geocentric explanations here. So for example, how heliocentrism explains the difference in the sky. An example would be an observer here would be seeing this section of the sky looking towards the sun, and then 6 months later, they would be looking in a different direction and they're seeing, a different set of stars. So this is the way that they interpret it for the heliocentric model. So the sun is doing a loop around, the Earth is doing a loop around the sun. Here's some more heliocentric models. So here we got some nice ellipses and circles, and it's all going around the sun here. We got the Earth somewhere in here, yeah, right here. So all going around in a circle around the sun. And for the geocentric models, where the Earth is in the center and everything is going around that, we have motions that look like this, and we have these epicycles here for the retrogrades. So we have various models that were put forward. So we got the neo-Tychonic model, where it's a merger between heliocentrism and geocentrism, and we got heliocentric model over here. And we just got some more patterns and outlines of the celestial bodies from our terrestrial perspective. And this would be from a geocentric perspective, where the Earth is stationary and everything is going around. So these are the kind of patterns that you would get from that, from the day-to-day motions if you were to plot them. All right, and we got the calendar of the eclipses. This is just what it would look like over a flat plane, spiraling out um, between the tropics and all that. So we got a quick video here of a magnetic of a magnet and a ferrocell, and it's just to show a relationship between the patterns of the orbits that they use for the geocentric model, following a natural fractal magnetic pattern. Just some cool stuff to look at and consider. So there's no audio to this. It's just a couple of quick visuals here. So we'll see these outlines, and we'll get into this. So we'll get into different variations of movements of what's going on with the celestial bodies in the sun, just everything that's going on in the sky. Next slide. All right. So again, we got, if you take the orbit of Venus, Mars, Jupiter, and Saturn, you look at them one by one. Like this is what you would be looking at to explain their motions in the sky from a geocentric perspective. And it looks a lot. You see a lot of the same fractal patterns with magnetic fields. Just an interesting way to look at it here. Again, got a little more of this. Same sort of fractal patterns. So getting back into the science of it. So hypothesis. If heliocentrism were true, based on the yearly cycles, the Earth is required to be in motion at a certain speed, a speed of 30 kilometers a second to be precise. In combination with that, the current electromagnetic theory was based on a stationary ether that carried the charge potential for an accelerating electric field to generate a magnetic field. That background medium that carries the charge potential for the electric to the magnetic field induction, will also affect electromagnetic propagation in the form of resistance to the speed of c if you're in motion relative to the ether. With that understanding of the rate of induction of c from Maxwell's equations and the etheric framework to provide the mechanism for the variance of c, Earth's orbital velocity should be revealed in the form of a fringe shift pattern. The variance in c should produce a fringe shift corresponding to the amount of resistance that the ether would have on a light beam that's perpendicular to the direction of the motion around the sun at 30 kilometers a second. Imagine that you're driving down the highway and you stick your arm out your car window. Your arm will be experiencing air resistance relative to how fast you're traveling through the air. So same exact concept that they were proposing here. So for heliocentrism, so to affirm the theory, to provide positive evidence for it, they surmised that they would need 5 fringes to get positive confirmation for the 30 kilometers a second. So each fringe would be equivalent to 5 kilometers a second in their scale. A null for them would be a no fringe shift pattern, meaning that the speed of light is the same in all directions and it can't be used to determine motion in this way. And falsify would be a slight fringe pattern that's repeatable and persist with further experimentation. So geocentrism, affirmation would be a slight fringe that's reproducible, like I was saying earlier. A null would be no fringe, meaning that you can't determine anything from the speed of light in this regard because it's not producing a fringe shift. And falsified would be 5 fringes. So heliocentrism's motion would be completely would have a lot of evidence put forward for it in that regard. And then the ether. So for the stationary ether framework, affirmation of that would be fringes, however slight, as long as they're outside of the air tolerance, and if they're repeatable. So for a null, I put slight fringes outside of the air tolerance and that are repeatable. And falsified would be no fringes, meaning that there's no variance, that there's no medium to facilitate a mechanism where there would be a variance in the speed of light. And let's see here. Okay. So we'll get into the Michelson Morley 1887 experiment here. They had a concrete slab on a piece of wood that was floating in a vat of mercury here. What they were doing with this is they were taking a coherent light beam. They were splitting it at a beam prism, and they were using these reflective mirrors to extend the distance that the light would have to travel, so that they could, get an accurate measurement of the effect that they were trying to get. But basically, all these beams would recombine, and then they would look for a fringe shift pattern that was to be produced. And that fringe shift pattern, depending on how much fringe there was, they were going to correspond that to the amount of motion that the Earth was receiving against the ether. So for experimental variables defined, the independent variable would be the orientation of the interferometer with respect to the direction of Earth's assumed orbit. The apparatus was aligned such that the arm was perpendicular to the direction of motion, which will cause it to experience resistance to the ether, causing a variance in C, which will produce a fringe shift pattern, which is going to be our dependent variable. Changing the orientation of the apparatus and taking measurements at different times will allow us to interpret the results and establish a cause and effect relationship with the fringe shift pattern and the assumption of Earth's orbital velocity and all that. So interpretations of the results regarding the hypothesis detecting Earth's motion: 5 fringes, each fringe corresponding to 5 kilometers would be a positive evidence for heliocentrism. No fringes. C is invariant with respect to the motion of the source or observer in combination with special relativity. One could turn that null into positive evidence for heliocentrism, which is what they later did. And slight fringe with a stationary Earth with respect to an ether wind, positive evidence against heliocentrism. So experimental variables defined: dependent. The dependent variable is the fringe pattern produced, and that's going to be either produced by Earth's assumed motion through a stationary ether or a stationary Earth with respect to an ether wind. The strength of the reading, i.e., the number of fringes with respect to the independent and control variables, will allow us to narrow down a cause and effect relationship between the fringes and the variables within the experiment and the axioms of the two models in question, i.e., is the Earth in motion, or is the sky in motion with respect to a stationary Earth, right? So for controlled variables, so just to throw some out there, we got mounting the apparatus at Mercury helped keep it level when changing the orientation and all that, and it helped reduce vibrational effects. So the first experiment that Michelson did in 1881 was too sensitive to ground vibrations and just local stuff going on in the environment. So it was giving air readings. So one of the solutions that they came up with that was to put it in a vat of mercury so that it would float evenly and be, independent of that, and they could move it and get it situated and all that. So additional mirrors were added to the apparatus to increase the distance that light would have to travel, so that they could get a stronger effect on light, so that they could read, or so that they could get a stronger fringe shift reading. And then taking readings at different times, taking the readings at different times a day to isolate the assumptions about Earth's rotation with respect to the orbit and all that. So they took readings during the day and during the night. So what the implication would be there is, are you rotating into the orbit, or are you rotating away from it, and how is that affecting the readings? So here's a topographical view of that concrete slab with the mirrors and light beam and prisms mounted on it, and what happens to the path of light and where it goes. So here's the data from the paper that they published. So here's the graph for their expected fringe shift pattern to confirm heliocentrism. So right here would be 5 fringes, and this would be the 30 kilometers a second. And let's see. So this is in the solid line is what they actually got. So they got just over 1 fringe. So their interpretation of this at the scale that they were using is that they got between 5.5 and 6 kilometers a second. Now you can read in different, or you'll read in various papers, like they'll say they got between 5.5 and 7 and 6 and different numbers, but it's around that range. So there's some variance to the interpretation or whatever, but it's way less than what would be needed to provide positive evidence for heliocentrism. So they were all befuddled by this. So step 5 from the scientific method process that we were reading earlier. So conclusion and deriving a theory based on the experimental evidence. So experimental results, the fringe shift produced was 1/6 to 1/8 of that is required to provide a first order measurement of Earth's orbital velocity. So theory 1 for heliocentrism, attributing the fringe to instrumental air and then later using postulates based on the invariance of C regarding the source and observer. You can formulate a mathematical framework to interpret the lack of fringe, i.e. Lorentz's ether theory saying that there was ether contraction, or later special relativity saying that there was space-time length contraction and time dilation. And using this new framework based upon the invariance of C, you can use the slight fringe in the experiment to have a correction mechanism mathematically. So this is the Lorentz correction, the Lorentz factor, they call it. So this is the amount that the apparatus would have to contract to not give you the full 30-kilometer reading and to only give you a 5-kilometer to give you that optical illusion. So this is the Lorentz factor. So this is what they ended up going with for special relativity. So note, in relativity theory, an observer outside of Earth's reference frame would not see a fringe pattern if they could observe the Michelson Morley experiment being conducted on Earth. So, for example, if you were on the sun and you had a magic telescope and you could see a bunch of little lads doing their light experiment from the sun, you would not see a fringe pattern at all, according to special relativity. And the only reason that we saw it in our reference frame is because the length contraction already happened. So therefore, we're measuring this slight fringe. So that's the explanation that they came up with. So for on the geocentric interpretational side, we could do so for the same exact interpretation. The fringe was 1/6 to 1/8 of that, which is required to produce a positive first order measurement of Earth's orbital velocity. So theory 2 for geocentrism, we could go with a stationary Earth with respect to an ether wind that follows the sidereal rotation of the sky. No second order corrections, i.e. length contraction or time dilation, or postulates are required for this interpretation. Normally, first order measurements corresponding to a viable hypothesis is the favored interpretation as it is the highest form of evidence that can be provided by an experimental result. But for some reason, they decided to go with length contraction and time dilation, which are second order corrections. So an important thing of that experiment, to recap at the end there of the history of it, their first interpretation of the experiment was that there was no fringe shift pattern, and what they saw was due to instrumental air. It was just air tolerance, right? So that's what they said at first. And then Lorentz was like, hey, maybe there was ether contraction in the direction of motion and all that. So they were like, oh, okay, cool. We'll run with that for a bit. And because this was all about, it wasn't just about the ether, it was about heliocentrism, and it was about the motion of the Earth. And the reason that they went with that was because it allowed for the mechanism to say that, okay, even though we got a reading that was way weaker than what we needed to, we can mathematically infer that the full reading exists, but we're just seeing a fraction of it because of this contraction mechanism due to our motion through the ether in space. So then Einstein came along in 1905 and said, this is the exact same mathematical framework that Lorentz put forward, and special relativity actually adheres to Lorentz covariance, Lorentz symmetry, and all that, right? So there's no that's not even like in dispute that they're the same framework. So Einstein comes along and says, "Hey, we actually don't need to say that the ether is responsible for the contraction of the mechanism. If we tie the x-axis, the direction of motion, to the to a fourth axis that I'm going to add called time, if we tie these together and have them contract hyperbolically, they can meet in such a way that the speed of light will be the same in every reference frame." And that's what they did, and that's what special relativity is entirely built upon, and that merging of the two of those two axes, space and time, is what is the mechanism that removes the ether from the framework of interpretation. So you know how you'll hear Einstein disproved the ether, or he removed the ether, and like, what does that mean exactly? Well, it's in reference to how he did it mathematically, and then explain the effects through what's it called? Explain the effects through the coordinate system changing, right? So this is why it was heavily rejected back in the day, because people were like, "What? This doesn't make any sense. There has to be an underlying mechanical mechanism and all that," because classical mechanics and the ether theory was all the predominant theory back in the day. So overturning all that, they had to special relativity has to be able to explain all classical mechanic effects in and then some, right? So in differentiating between a relativistic effect and a classical mechanical effect is actually impossible. So it's just kind of presented in this way that this is what's been done, and everything, and then everything moving forward is like retroactively a relativistic effect. So that was the framework that they jumped into to explain the Michelson-Morley results to keep the motion of the Earth. And these are experiments that replicated the Michelson-Morley experiment and actually took it a step further and found a cause and effect relationship with what one could consider a local sun, which we'll get into later when we get into Dayton Miller here. But to close out, I'm going to get into the history of interferometry and go over the experiments that replicated these effects and show that there's a variance to see, that show that there's an absolute reference frame, that there is a background medium, and that all motion is relative to that. And that's what facilitates the variance in speed of light, and that's why the speed of light is relative to the velocity of the observer. And that the ether provides that mechanism, right? It's not just like light just decides on its own, like it's omnipresent. It's like, oh, this guy's moving, I got to go faster to catch up, or move slower. Like, no, it's not what's happening. It's relative motion to the ether, and that's what's been obfuscated through this experiment. So we're going to go over experiments after this, or after the Michelson-Morley, that show the same thing and actually take it a step further. So we got Michelson-Morley here, 1887, Sagnac, again Michelson and Gale, Miller, DeFore and Pruner, Yuri Galev, Wang, and Manira. So we're going to touch on their papers real quick, and we'll close out, and then we'll get into a Q&A on everything. So for Michelson-Morley, we already went over the predicted fringe and what they measured. And these are the this was just going over the control variables. So this was in reference to them putting the apparatus in a vat and taking measurements at different times of day and all that. So this was their experiment and their fringe reading. And remember, they got just over a fringe, but they ended up saying that it was experimental error, even though it was outside of experimental error, but it just didn't match heliocentrism's predicted amount. So they were like, they didn't know what to do with it. So they just were like, I don't know, maybe the apparatus is broken, dude. So 1913, Georges Sagnac came along, a French physicist, and with a rotating interferometer. So I don't have a graphic here, which is a mistake on my part. I apologize. But if you just recall to the Michelson-Morley device and just imagine it in a circle, right, or a triangular configuration, and then it just rotates constantly instead of being stationary when it's taking the readings. That's what this guy did in 1913. So he had a rotating interferometer, and he produced a fringe shift pattern. And so special relativity's answer to that was, hey, this is a non-inertial reference frame because it's a rotating device. So the speed of light, we're not really concerned that it's changing. So it's not a falsification. And then later in 1918, Paul Lavue, using a special metric tensor that he and a couple other people derived to explain angular momentum conservation on the small scale, they were able to say through general relativity that the rotation of the device was equivalent to generating enough energy to make time dilation and length contraction happen. And so they explain the Sagnac effect through general relativity, through rotation, and saying that the energy of that is equivalent to generating what would be required for the apparatus to length contraction and time dilation to happen. So they co-opted this experiment, and then of course through the equivalence principle, general and the general and special theory are linked together. So while they couldn't explain it through the special theory, even though they have means of deriving uh, circular explanations through relativity, your circular rotation, they didn't want anything to do with this, but they did bring it in through the general theory, and this is how they did it. That's the mechanism by which they say that it works. So they explicitly say that the Sagnac effect is due to rotation, and it's not due to any sort of preferred direction or anything like that. So they've kept it within the confines of relativity in that regard. So 1925, this is Michelson and Gale and Pearson. And what these gentlemen did is they built a giant underground interferometer. They vacuumed out these tubes here, and they measured a variance in the speed of light relative to the latitude. And the way that they explain this through heliocentrism is they say that that the Earth, so the Earth is rotating 1,000 miles at the equator, and then so like at the 45th latitude, it would be rotating at like 750 miles per hour or something like that, and then at the North Pole, it would be rotating 0, right? So that speed fluctuation, they say that rotation relative to the latitude is what is causing the variance in C there. So that's how they extrapolate the they use this experiment as evidence for heliocentrism by saying that this is verification of Earth rotation, even though this apparatus is exactly the same as the Michelson Morley apparatus, which I'll get into how all these interferometer experiments are essentially the same. I'll get into that towards the end. But the mathematics that they used here, they say, so just to point it out real quick, they say that this is based on Earth rotation, and the velocity and all that is derived on an ether fixed hypothesis. So what they mean by ether fixed hypothesis is they're using a fixed reference frame to measure the relative speed of light going from the pipes going east to west and the north-south pipes. And that's where they're getting their variance in the speed for the measurement. So when they say that they're using a fixed ether and all that, like that's what they're talking about. So they didn't do any relativistic corrections or anything to derive this. This is just looking at it and saying, how fast was the light going on these pipes, and how fast was it going in these other pipes facing a different direction, right? Let's see here. So they do make a note here that says that this prediction or whatever is in accordance with relativity, but not sure how that could be if they didn't want anything to do with Sagnac's thing, because what they end up saying as well is that Sagnac measures Earth rotation as well. So all the while after the Michelson-Morley experiment happened, so from 1905-ish to 1925, a man named Dayton Miller conducted, forget how many experiments it was, but he did 5,200,000 measurements of interferometry measurements throughout the year, or throughout 30 years, rather. And then, taking the measurements at different times throughout the year, he found that there is a fluctuation in the speed of light that varies corresponding to the motion of the sun. So in the northern hemisphere, the translational speed of the sun meeting 15 degrees per hour would be slower, right? Because it has to cover a slower distance. And if we live on a plane, it has to go faster. So it, as it goes into the southern hemisphere to maintain the 15 degrees per hour. So that fluctuation in speed, Miller measured to the day on the equinoxes, where the fringe shift patterns reach their minimum and maximum dimensions on the equinox to the day. And he did extensive repetitions of this experiment, doing various control factors and and accounting for criticisms of his experiments, mainly temperature variations and seasonal effects and stuff like that. But when you plot his data against diurnal seasonal time, there's no cause and effect relationship with the variance in C. Well, when you plot it against sidereal time, i.e., what's going on with the sky, it shows a fluctuation corresponding with what would happen if the sun had to pick up its translational speed. Like if the universe itself or whatever was rotating faster, then the mechanism to facilitate that translation of motion, the ether, the tailwind that the light is catching, right? That's making it propagate faster. That fluctuation is happening. Is what he's measuring essentially, right? Now, just to throw it out there and not present it as if this is explicit flat Earth evidence or whatever. But Dayton Miller was a heliocentrist, and the way his interpretation of it is how they say the Earth is on an elliptical orbit, and to facilitate that, the Earth would have to be 4 times a year. The Earth would have to be going slower and faster. It would have to go through that mechanism to complete its orbit. So that was his interpretation of what he was measuring, but just at a way slower amount. Now, through different correctional factors, of course, you can get into. They can extrapolate whatever kind of motion they want out of it. But I just wanted to put that. Just wanted to represent that accurately, because the way I went into the first explanation of it was for a flat Earth of it. But so his interpretation of it was that he made the heliocentric measurements that Michelson didn't measure, but he just measured them to a way slower degree. Now mainstream science had already moved on from this point, because they said there was no ether, all motion's relative, can't measure it, and they couldn't risk more people measuring the variance of C in relation to Earth's motion and getting something that doesn't correspond to what would be needed to facilitate heliocentrism being true. And so they just hand-wave dismissed his work, after he died. They character assassinated his work when he could no longer defend himself. But while he was alive and doing the experiments over the course of 30 years, his work speaks for itself. So, and I think I added some quotes of what Einstein said about it, and I'll read it later at the end here. So moving on to 1942, we have Dufour and Pruner, who, so with the rotating Sagnac device, they attributed that effect to the rotation of the device itself, right? So what these two gentlemen did is they just had a circular device set up that wasn't rotating, and what do you know? They started getting the same readings and the same variance, and they couldn't, relativity couldn't explain it. So Paul Lavue came in and was like, "Hey, I got you on that math." And what he found was that, so in relativity, the speed of rotation at any point of a rotating disk could be explained from any position on the disk, any reference frame on the disk. It shouldn't matter. And what they found with this, how relativity was trying to explain the variance from the center of the disk, they couldn't make the corresponding predictions show. It showed that there was a preferred reference frame, and Paul Lavue couldn't save him on that one. So this was Dufour and Pruner. And then here in 2002, we have Yuri Galev reproducing Dayton Miller's experiment. And this is especially important because what Dayton Miller found was that when you go to altitude, you get stronger readings for the ether wind effect, meaning that the translation of motion is coming from the sky and it's not coming from the rotation of the Earth or anything like that. Like there would be no reason that there should be a discrepancy on the globe. The reading should be the same at any altitude. So this is Yuri Galev doing the same experiment with optical wave bands, and then he later did it with radio millimeter bands as well. So this is his data plotted over sidereal time as well, showing the same relationship where it fluctuates to the day on the equinoxes. And this is from his other I think this one was from the optical bands, or this one was from the radio band. Yeah, this is from the radio bands. So this was from the 2002 one. Okay, and then in 2004, we have the generalized Sagnac effect by Ruyang Wang, where this gentleman took a fiber optic cable made a conveyor belt situation out of it here. And what they expected to find was that the bits that are rotating would be the bits that would contribute to the rotation. Um, or I'm sorry, there that the rotation of the that's going on right here on this part of the conveyor belt is what would contribute to the fringe shift pattern. But what they found is that this linear motion also contributes to it. So the later explanations for the Michelson-Morley experiment and how it couldn't measure Earth's orbital velocity because it's a linear speed and all that, and Earth's traveling on a geodesic path and whatnot. They got rid. They said that they shouldn't expect that fringe pattern and all that. So they they apply second order corrections to Michelson-Morley, and then for the Sagnac effect, they say that this is just Earth rotation, so they don't have to apply any special corrections or anything like that for that. But what this is showing is that this effect that they said was explicitly due to rotation is due to more than just rotation. This is due to which direction the device is actually orientated. So every time he would orient this, or would change the orientation of the device, what he found was that the readings going east to west, the propagation is faster, and when it's going west to east, it's going slower, and it depends on the direction, and it's not due to any sort of rotational effect. Otherwise, if it was explicitly due to rotation, as they need it to be, really, to provide heliocentrism evidence through relativity, only the rotational bits should be contributing to the fringe. So just to recap what that means mathematically here. So for the circular derivation, we have delta t equals 4 omega a over c squared. And what they're saying here is 4 times the rotational speed of the device times the area of the device over c squared will give you the amount of fringe shift pattern produced. So what Wang did in his experiment, he had a linear equation, which is he had your delta t, which is your fringe shift pattern produced, is going to be equal to 2 times the velocity times the length of the device over c squared. So the key important parts to note here is that it's the only thing that's important here is the motion, right? So the velocity, the linear velocity, the rotational velocity, all are producing the same effect. It's not just due to one or the other. And also, of course, corresponding to the direction as well. And then your area is just the length of the device, so the length that the path of light has to travel. So in a fiber optic cable, if your cable is 1,000 meters long and it's in a spool, it's going to be, your area is going to be 1,000 meters. So same concept with the length for the linear conveyor apparatus that Wang made. So this is Hector Minera in 2006. This is they made a classic Michelson-Morley interferometer. So no rotation or anything like that. They just had it fixed, orientated to the direction of what they assume would be Earth's orbit and all that. And they left the apparatus in this experiment. They left it running for 3 years continuously. And what they found was that they matched Dayton Miller's work, but the way that they interpret it is they imply a different set of correction factors to it, and they say what they're actually measuring is the motion of the galactic motion, right? So the motion of the what is it called? The sun through the Milky Way or whatever. So they just, through a different correctional mechanism, they just got a higher number out of the reading, but they measured the same thing over 3 years, the same fluctuations that correspond relative to the day on the equinox. So to close out here, we're almost done, I swear. Thanks everyone for listening. So to close out here with GPS, what Wang pointed out about the relative, about the speed of light being relative and proportional to the velocity of the observer. The accuracy of GPS reflects this using its range measurement equation and the ECI reference frame, which is a stationary non-rotating reference frame. And the range measurement equation is basically just a time interval system. So what they're doing is just taking a snapshot of when the signal was sent and when it was received, and the difference in the speed of propagation that it would take to get to, the distance or whatever, right? So that's how they're coming up with GPS accuracy. And what they found was, so if you have a stationary receiver here and a moving receiver here, and you send a signal at the exact moment that these two are intersected, the moving receiver will receive his signal with a delay that'll be proportional to his velocity, even though the distance that these two gentlemen are the exact same. So this is a huge contradiction to special relativity. This this is an exact prediction of what would be this is exactly what you would expect if there's an ether, right? All motion would be relative to the ether. Electromagnetic propagation would be relative to it. So your motion relative to the ether would change how you receive the speed of light, and that's the accuracy of GPS with a first order measurement is entirely dependent on that, and that's how that works. So the velocity of the observer is proportional to the delay in which they receive their propagation of light. And I had a video here of Ron Hatch reiterating that, but we've been listening to me speak for a while, so I'm just going to skip ahead here to where they show it in the frame from the manual. Let's see, 1 second. All right, since the receiver... oh, shoot. All right. Well, whatever. Anyway, to close out here, it says that, since the receiver is in motion or whatever, you have to account for that, and just do it, don't worry about it, blah blah blah. And that's a direct contradiction to relativity theory, because if relativity theory were true, then those two receivers should receive the signal at the exact same time if they're at the exact same distance in that moment in time. So at the end of and then I wanted to close out here. So this is a hot topic in flat Earth and all that, and in the argument of geocentrism versus heliocentrism and all that. So just wanted to say, at the end of the day, we all believe in different things, and that's okay. My buddy Jim Waterworld said that, and I think that's a great quote. So with that being said, I'd like to open the floor to anyone that has any questions. I'm happy to discuss.
Nice, dude. This is great. Yeah, and I got a question, but it's kind of a long one. So you started with, is Michelson Morley an experiment? And I think the easy answer is a resounding yes to that. I went through the components, what makes an experiment. You outlined the method. We outlined the types of variables that we use and how they were manipulated to derive the results that they got. And then I think we can say there's an overwhelming series of measurements of the motion of something, right? Whether it be the translation motion from the sidereal rotation of the sky, or what they've misinterpreted as Earth motion. There is a measurement of motion. There's millions of measurements of motion, and the only two possible frameworks that I can think of to interpret this motion would be a stationary ether and a moving Earth, or a moving Earth and a stationary ether, right? So then I can't see any other way in which those measurements of the Michelson Morley and subsequent experiments can be interpreted. Do you know of any other framework in which that data and measurements can be interpreted?
No, if you have a different, the only way you could interpret it differently or whatever would just be to hand wave dismiss it wholeheartedly, right, and just not acknowledge the significance of it or the implications either way, because you have to to acknowledge it and go through it and look at it and understand it. You have to have a framework of interpretation, or at least understand the two frameworks that are put forward and why why they had them, right?
So then what would you call a person with a stance that, I guess, negates all these measurements and doesn't say anything? Like the people who poo-poo on the ether and the interferometry stuff and don't understand the relevance of the variance of the speed of light and the Sagan effect. How would they interpret these, let's say Dayton Miller's 5,200,000 measurements with interferometry showing this pronounced effect?
Well, you would have to take an actual anti-science approach, right? Because these were science experiments that were done. These are repeatable effects by all standards. They should meet the rigid natural science approach, natural phenomenon, right? Electromagnetic propagation is a natural thing. They have a framework to interpret the speed of that propagation. They can accurately make predictions based off of it and all that. So I don't see why it would why you wouldn't use this or make an effort to understand it and utilize it, because it's a powerful weapon once you realize that the interpretation of it is just that. It's an interpretation, based on trying to fit it into a framework that doesn't, through unscientific means to fit it into a framework that is claimed to be scientific, when the scientific interpretation of it was there the whole time and doesn't require any crazy corrections or reference frame transformations or abstract math to describe it.
Right? Rock on, man. I mean, yeah. Well, does anybody else have any questions, comments, concerns? Because I mean, like the more important part, and the thing that we reiterate every time, and the thing I think about every time I hear you give one of these presentations, which is like 12 now, I think, is that all these serious interferometers and these measurements with such sensitivity that they had to put the device in a pool of mercury to stop getting the gentle quakes of the earth interfering with everything. They are all well within the threshold to measure Earth's orbital velocity, which was the original intention of setting up these experiments and was the original intended fringe pattern to measurement. That's what it was based on. They would try to detect that, and then they tried to fit it into a pattern where they could actually detect half of Earth's a spinning motion, and we'll call that heliocentrism, even though we firmly needed both of these measurements, and one is substantially more measurable and more vicious and violent than the other. So we should, if we can detect one, we absolutely unequivocally should be able to detect the other. No one's ever done that.
Yeah, absolutely. And especially with what Wang showed in 2004, like the significance of that is that they absolutely should be getting the readings to that because, um, they turned around and hinged everything on a linear geodesic path and all that. So it's like Wang came along and was like, "Hey guys, I got great news." Turns out it should be measured.
Well,
But even on top of that, GPS should also reflect that as well because the motions should be added together if the Earth is spinning into the orbital velocity, right? And it would have to be because that was the explanation for length contraction and time dilation. So they've already capitulated to agreeing to that mechanism existing, but that measurement doesn't exist in GPS. So that's a direct contradiction as well to the interpretation of length contraction and time dilation of Michelson Morley.
right? And like the magnificence that is Wang, the linearization of the Sagnac effect. Like for those who haven't done or like look into what this would mean, it means that for the entirety of this debate, right? We've compared interpretations of the motion of the translational motion of the sidereal motion of the sky. They said they've measured Earth's rotation, with actual interferometry and the historicity of the signs of the movement. You find they've just been measuring the motion of the sky with varying degrees of specificity with a whole bunch of instruments. So what Wang did by linearizing that effect and removing angular rotation as a cause, said that actually you can no longer take the interferometry measurements of the sky and associate that with Earth spin. That's not what that is. That can no longer be done. So when the whole debate has been about the different interpretations of the measurements of motion, they are now definitively in the flat Earth, stationary Earth moving rotational ether camp. That's why it's important.
Yeah, absolutely, man. And then so looking further into the Wang experiment, you can even find some papers, or there was a review that someone did on it that showed how, because of how he directionally orientated the device and because of its conveyor belt nature and its motion versus the assumed Earth rotation and all that, and how it would cancel out, he actually created a lab frame that is equivalent to actually being at rest. So he showed that because of the how the effect still persists through that the Earth is stationary with respect to an ether wind, which is a very important distinction because when you look at the history of the ether theories and all that, everyone on all these big physicists and big name mathematicians and all that all have varying theories on the ether, and they were all trying to explain different phenomenon of the ether, and they all, but fundamentally, they all actually adhered to an Earth in motion and stuff. So a lot of the interpretations that you'll hear about a stationary ether or an ether wind is in respect to a mechanism that's facilitated by the rotation of Earth and all that. But the difference here is like it's literally just a coordinate system transformation to reinterpret it as a stationary Earth with respect to an ether wind, and that's actually exactly what the ECI reference frame, how you could interpret that with how they use it in GPS, because that's actually like that's why they use it, because it's stationary, non-rotating with respect to an ether wind. And so the effects that they measure in that frame which is the variance in the speed of light, which is what is producing the accuracy of GPS, is all facilitated by that.
Ether tech, as you would call it. So all this technology is based on this known and taking advantage of preferred propagation for directional speed of light, and then they turn around and say, actually, no, it doesn't exist. Like, well,
Yeah,
actually, well, satellites wouldn't work with the range measurement equation based on the quantification of the induction and the rate of illumination, which we now have a useful quantification for, and a metric that we can use to, do simple tasks.
yeah, exactly, dude. So not only is it ether technology, all all electromagnetic propagation, excuse me, is ether technology. One second, I'm looking for the equation here. This oops, it's not it. This one. So we've all heard of Maxwell and Maxwell's equations and all that. Um, so before Maxwell made changes to what's called Maxwell's equations, what his further contribution to the equations was what he added this term here that says that you don't need any charge potential for an electric field to generate a magnetic field, when in fact that's never been experimentally verified. So this mathematic term here I don't know if you can see my mouse highlighting it. Can you guys see this?
Yeah.
Highlight. Okay, you can see it, so you're good. So anyway, this term here is just saying that if there's no charge potential, it'll still propagate and the field will self-induce a magnetic field. But this is done with no experimental evidence. In the 150 years since these changes were made, and also a change was made to Faraday's law Ampere's law no, maybe it was Faraday's, to compensate for this change because it's a contradictory term here, the way that he did this. But yeah, there's never been an experiment to show that that an electric field can self-induce a magnetic field, so it can't create a wave like that. That's what this guy's whole paper was about. He goes over radio wave propagation and the changes to the equations. It's a very interesting paper. What's that?
So you're saying that like electromagnetic waves needed an energetic background through which to propagate through to actually extend themselves, not to perpetuity, but past the point of attenuation of any normal wavelengths of light. But now,
Yep. Let me see if I can pull up this picture I took that'll help
but
explain. That'll add a graphic to it. But yeah,
so if they remove the background that they needed, the energetic background through which it needed to propagate, then they mathematically said, well, actually, the magnetic field induces the electric field. The electric field induces the magnetic field, and they will, self-masturbatory propagate each other into infinity. And then that's how that works now mathematically. That's insane.
yeah. Oh, I didn't take the picture, but let me see if I can pull it up here. Yeah, that's exactly what they said. Photon dipole diagram. Nope.
So before they were like based in logic and reason, and they were like nothing can propagate forever. It has to propagate through this energetic background, and everyone agreed. And they were like, actually, no, we don't need that. It'll just self-propagate itself in perpetuity with nothing needed. And they were like, yeah.
Yeah. So, so the only way to create a radio wave, right, an electromagnetic wave, is for the charge potential to accelerate. So the acceleration of that will cause the electric field to accelerate, and that acceleration induces the magnetic field. So if you look at this diagram here, you have the acceleration of the magnetic field, and then perpendicular to it is the magnetic field, right? So at the intersection points in between here, there's a charge potential. That's what mathematically is being talked about here with this variable here, permeativity or permeability. I can't remember which one, but that's what that's saying, right? Like what's carrying the charge potential and allowing this field to induce another field. And when he added this term, right, he said that, well, you actually don't need anything at this intersection point to facilitate that field generation. That just the movement of the electric field uh, will will uh, will self-induce that magnetic field.
Does anyone think that's scientifically well reasoned and no problem? Like,
Yeah, it's really interesting when you look into it because it's like we've never not been in an ether framework. People have just done some fancy math to like act like it doesn't exist and disguise
you
the
know,
effects of it as length contraction and time dilation, which is like a
now that
nonsense. Like imagine the power you would have over people if you were in like a secret society that like did like science and all this stuff like at the cutting edge of all this, and you understood the ether and propagation and all that, but you had everyone else thinking that like that doesn't exist and that there's a second order correction that has to be applied, like a literal fairy tale that you have to correct for. And because you do it mathematically, you think you're part of the fairy tale and you think it's real, but it literally goes nowhere and has no purpose and describes nothing that has any relationship to do with the phenomenon that you're observing in reality.
that's the crux of it, though. That's the trick of heliocentrism, essentially. The mathematical transition. It's a mathematical coordinate system transform from a planar to a conical system with a feeling of infinite height. And there you go. The best way to describe it.
Yep.
They took
All
away
right.
the theoretic framework and gave us crap, and that's why nothing's ever progressed since. But this is great, man.
Yeah. Yeah. Einstein's theories were brought in and to stifle a physics revolution, right? Because imagine the implication of like, oh, the Earth's stationary. There's an ether background. Like, imagine the direction of science that of how things could have went in terms of energy harvesting, utilizing technology, being honest about how it works,
Right.
and
Couldn't
and all
have
that.
that.
Yeah, and not having like these things where it's like, oh, the only way you're gonna get brought into the fold is if you like uh you're participating in one of these like government funded operations, and then like they pull your work because it's actually relevant to some other project that they know how they know how the actual mechanism works, and they bring you into it and like sort of thing. So it's like very secretive, and there's not going to be like an open discussion about it, and that's what's allowed this stifling of it, right? And then so through that, you just have everyone running around doing these nonsense calculations, living in a Dungeons and Dragons
Well, and
relativistic
then
overlay.
like when they're trying to repeat these experiments, they're not trying to repeat them with the accuracy of Dayton Miller to get the same results. They're like, what we got to do? Let's do them worse. Let's put them in basement. Let's make the arms different lengths. Let's do
Yeah,
everything we can to fuck up the results of these measurements so that we can get as close to zero as possible.
dude, how about this? They do all that to ruin their own accuracy of the measurement, and they still get a measurement.
Right? Yeah.
They
Of course.
can't not get away from it. They of course they attribute it to instrumental error at that point, but
Dayton Miller's like,
but they're still in effect. And Dayton Miller literally called all of the effects that they would use later on to discredit him experimentally and use this tending towards zero,
right.
and how they would facilitate that by changing the dimensions of the arms of the apparatus, the medium of the tubes, and all. It's just like cool,
Dude,
man.
that's so ridiculous. He was like, hey, guess what? If we go closer to the sky, the changes more. They were like, interesting. Word? Let's do it in the basement with different fucking length arms. It's like, what?
Let's do it in the yeah, let's do it in the sub basement. Ugh, it's like what? So,
Also,
but yeah,
I
but
don't
yeah,
think any
that's how they
Glovers have.
roll.
I don't think all the
Yeah,
Glovers left.
that's cool, man. Well, if anyone has any questions about the experiment or anything like that, hit me up because otherwise, I'm gonna go ahead and end my stream here, and then we can go on discussing whatever else we want.
So quiet. I think that's like your superpower, man. You quiet a whole room. None of the Glovers want to talk anymore.
That's because Michelson Morley just disproved the ether.
Right? Like how dumb does Wikipedia
Yeah.
seem with all this context now?
Yeah. So exactly what Napalm said, man. Like if surface level narrative of this is like it's framed in a way that's super positive for heliocentrism. They try and make it seem like it's very cut and dry, even though they're applying relativistic corrections for this experiment and not another experiment, even though they're literally the same. And you know, it's really fascinating. And but the big takeaway is just like, as long as you can disprove the ether, you're good to go. Right. Like they don't want you to look into the other aspects of it, or they don't even really talk about why people, like what it means for everything to be relative to the ether, for all motion to be relative to an absolute reference frame, and why the speed of light varies relative to your motion, like like how the ether is the mechanism that facilitates that. So it's like, if that effect exists, like you can logically just deduce, like, oh yeah, there's a background medium. Like it's
Actual
not,
profundity.
There's
yeah,
no
like
background medium because we can shine light through a vacuum where we've evacuated everything. So, what say you about that? Huh?
yeah. So the propagation through the vacuum is exactly why why there is a background medium.
So, you're telling me we can't have waves without something waving?
I mean, what's the natural antecedent to a wave, my dude? Something to be waved in, right? Some sort of medium to facilitate that motion.
Space time. Space time.
Exactly, man. And that's why it's like, space-time's the fabric of the universe. And it's like, what the heck does that mean? It doesn't mean anything, man. It just means that some dudes came up with math that abstractly conforms a coordinate system to the variance of the speed of light proportional to how much that variance was, to make it seem like light doesn't vary. It's like, oh, cool, man.
Right. Do you think that they came up with space time as a conceptual idea that has physical effects, even though it's conceptual, because they needed the physical effects that ether had in order to even perpetuate their bullshit to begin with?
I think that it was such a catastrophic failure that they didn't get a friendship pattern corresponding to what they would need to say the heliocentrism is real, that it just freaked them out really bad, and they were panicking, right? Because when you look at Einstein's math and his framework and the history of it, it's actually all plagiarized. He contradicts his theory in his own works. He writes people in private letters, directly contradicting things that he says in public letters about his theory. For example, he says that he had never seen Lorentz's theories or anything like that about the ether contraction or anything like that. And in a private letter to his wife, he wrote that he needed to, step away for a little bit and focus on Lorentz's explanation to the Michelson-Morley experiment, and like really analyze what was going on with the motion of what is it, moving bodies and electrodynamics or whatever. So like he already knew about the Michelson-Morley experiment. He knew about Lorentz's theory. He knew about all of it. But publicly he's like, oh no, I don't know nothing about it. Like, and then he'll later say like, oh, I was thinking about it, the Michelson-Morley experiment on my own, but he doesn't reference Lorentz's work. And even though his entire work is predicated on Lorentz transformations that adheres to Lorentz covariance, Lorentz symmetry, and all that. He doesn't give him any credit in his work, and he says that he didn't do that, or he came to this on his own, but it's literally the exact same framework, identical, and it's just like stitched together, and then through how they had to change the math to evolve it to establish and maintain covariance, which is how they were establishing the quote unquote known laws of physics, and how they were going to transform them to different reference frames, and maintain the validity of saying all, the speed of XYZ is the same in all reference frames. The mechanism by how they were going to validate all that, they had to change the mathematical framework. So when they came up with, when Einstein started using absolute differential calculus and he started using metric tensors, they could change the boundary condition, or the the input initial condition, or the boundary condition. So meaning the space-time metric tensor, or the um, or the stress tensors that basically are your conservation laws, right? So they can get any result they need to out of the math. So um, it was really appetizing for them to like put forward this framework, because you could literally explain anything with it. and just use by swapping out the necessary tensor. If you have that freedom, you can literally turn anything into a relativistic explanation. And I think that was like a big goal that they kind of realized or like came to as they were trying to cover up the Michelson-Morley experiment. And when Einstein's work was, coming through, even though it was like all plagiarized and stitched together, they were like, we have to put this through because, it gives us such leadway to explain everything.
Yeah, so it's like Einstein adopted the Lorentz contraction, but gave it no physical mechanism because he understood that he needed a physical mechanism within
No,
his theories, right? Is that kind of the
no,
idea?
he removed the physical mechanism, meaning the ether, because if there's an ether, then there would be a variance in the speed
Right,
of
but he
light.
kept the math.
Right, right. So, but the way that he removed the physical mechanism, though, was saying that there's no ether, and that the math, like the description, the coordinate system, conforms to C through length contraction and time dilation. Does that make sense?
Yeah, but he had no like actual physical evidence for that, right? It's just
Oh yeah. None at all. None at all. So that's why the general theory, why they had to like rush it through with such with such hastiness, really. So it was linked through the equivalence principle mathematically, so that gave it some bolstered credibility to what they were trying to do with it. And then they gave two calculative predictions with the theory, which doesn't really mean anything. So the big thing that they needed was for Eddington's observations to be true, so that they could establish a cause and effect relationship with the description of space-time to say that, okay, this is actually a description of the physical mechanism that's causing this shortening of a wavelength, that's causing the contraction of an apparatus and all that, right? Because otherwise it's just abstract math. And they didn't get the cause and effect relationship results that they needed, and that's why the whole entire story about Eddington had to be it's told to us like he made these measurements and saw starlight bending and all that, but when you look into the actual story, what you'll find is that he only seen displacement in the so-called solar limb of the sun, which there's already assumed to be a medium of a magnetic field and a electric field and a what's it called, plasma and all that, and the dense conditions, with regards to that. So to extrapolate that any displacement, if there was any, that it was solely due to space time, contracting around the sun, you couldn't make that cause and effect relationship. And then actually, if you go to Stellarium right now, go to 1919. May 29, 1919, go to the island of Principe off the west coast of Africa and look at the solar eclipse. You won't find any stars near the solar limb. They made the entire story up so that they could reify the mathematics, so that they could booster both claims and hide the fact that the Earth's orbital velocity has never been measured, and they
Yep.
and that their commitment to removing the mechanism of the ether was a solid move, because what they actually found was that space time is contracting and all this, and gravitational fields, etc. So the space time mechanism, they linked the equivalence of that with acceleration to gravitation with the equivalence principle with the general theory, and that's what allows them to explain anything through these mathematics, through this framework, through special or general relativity.
Well said. That was a good one. It always keeps coming back to that pesky Earth's orbital velocity, right? The easiest thing they should definitely have a million times over, and have
No, dude,
been
they
so
should have.
elusive. Yeah, they've never found it. Yeah, it's like the Wile E. Coyote chasing the Roadrunner, dude.
Yep, it's purely a mythological beast at this point, right? It's literally like a centaur. It's like, did I just see Earth's orbital velocity? Did I get the reading? And it's like, no, but I did draw a bunch of abstract math next to the reading that infers that the reading could be extrapolated into a bigger reading. And it's like,
Dude,
all right, cool, man.
They were like, I didn't get Earth's orbital velocity, but someone stamped their feet in Australia, and the ripple that it caused through the Earth actually messed up my reading. So we're gonna have to put it in a tank full of mercury to make sure that doesn't happen. Still no Earth's orbital velocity. I wonder why.
Yeah. And I mean, the implications, it's pretty straightforward too, because it's like, if we're not orbiting the sun and that's not existing, and we're not rotating, and you can't explain these effects through rotation, then we're stationary. And if mass isn't attracting mass in the way that they say it is through gravitational effects and through space time, and it's more of a pressure mediation um, through a medium. And it's like, oh, then they don't have a way to say like, oh yeah, we're a rotating ball. Like
Right.
it takes away so much of their ability of the
So
overlay that they have on reality with the
so many of the
mathematics.
tenets are struck at the heart by the foundation that you're trying to lay. I mean, like, well, most of your work is just bringing the legendary work of the old G's to light in a nice, cohesive manner to pass on. But most of all the measurements and experiments have been done by the legend of history who have been buried and not taught to any of us, the likes of Dayton Miller.
Yeah. Yeah, absolutely, man. If it was as cut and dry as it seemed, with the thing like Thanks Bob and all that, like we would have readings at the equator from these gyros, we would have readings in the south, but they keep that data obfuscated. We don't have single axis gyro readings in the south or the equator. Like all of these things would provide make or break um, evidences, for the
Right.
globe and all that, and that they're just not there, and they explicitly use things that are in the southern hemisphere. So in terms of single axis gyros, they actually make it a point to have two labs that are around the same latitude, around the 45th latitude, and their correction angle to Polaris, they say that they're actually aligning to Earth's axis of rotation to get the strongest readings to get their like 15 degrees per hour and all that. So they make it publicly available and known that their correction angles are about 45 degrees at these latitudes. So it matches what would be consistent on a flat Earth, right? If you're just aiming
Right.
at the sky
Because they're equal
to
at
get
that
to
point.
get these measurements, and this is single axis gyros. Keep in mind, or ring laser gyros. So for like an inertial navigation system, you're not going to be changing the orientation of it or anything like that because it has an additional gyro per each axis, and then it has additional, depending on the apparatus, has additional gyros mounted as well to take those readings, so it doesn't have to change its orientation or anything to get the readings. It'll just figure it out by averaging out how much it's getting a reading. So, but these things would be like really solid. Like this would be stuff they would be doing in high school. Like how they do the Cavendish, and they're like, oh look, the balls and all that, and they used to do that in high school apparently to prove mass ejecting mass. They would like schools would have like their interferometer, the single axis interferometer at their high school, and you would measure the daily rotation relative to your latitude and all that. Like it would be like a huge thing if this effect existed in the
Yeah.
way that it would have to be symmetrically to prove a globe in the way that they tried to co-opt the explanation for it. And the
The,
fact that stuff doesn't exist and it's obfuscated and hidden just kind of tells me that it doesn't exist for a reason.
Yeah, the other thing about those readings in the south and talking about the skies, like as far as the celestial sky optics goes, and like the optics induced kind of rotation of the South Pole, that I'd like to argue, since we can't actually measure any other rotation aside from the one around Polaris, it would lend itself to logic that there is only one rotation of the stars in the sky all over Earth. There is no second counter or partial or quadruple or anything like that. Or we'd have measurements that would indicate something like that as far as an alignment to an axial rotation with an interferometer, right?
Yep. Sorry, I didn't hear what you said. I just agreed blindly, but I'm
Yeah,
sure it
it's all right.
was
I was right.
pretty cool. Tight, tight, tight.
Those pesky southern axial aligned interferometer readings.
Yep. So in combination with repeating Miller's work, that's pretty huge, right? So we have, let's see how many people repeated his work. All right, so we got Miller himself, who did it for 30 years straight. So how do you count that? Do you count that as one singular guy doing it? I feel like if you do 30 million or 30 years of experiments and 5,200,000 measurements or more, like that.
That's like 1,000 legendary G's.
Yeah, okay. So this was replicated 1,000 G times, right? And it was replicated here by Yuri Galev in 2001 and in 2002. and it was replicated by Monera in 2006. And it's like, why aren't more people doing this and replicating it? And I bet you there's not a lot of funding in disproving the biggest lie in history. So, all right. With that said, I'm going to go ahead and close the stream out.
Hey,
What's up, G? Oh, what up?
hey, what's up, buddy? Hey, so like the guy that was doing the interferometry with the radio waves, like
Yes.
what? Can you kind of explain like the significance of like what he did?
Yeah. So just using a different type of electromagnetic propagation and then a different device, and he was just sending out the signals, and they were, propagating faster or slower corresponding to the equinoxes.
Oh, wow. Okay, I get that now. Thank you.
Yeah.
That's another interesting tidbit, right? Like, so if we are measuring the motion of the sky, and the motion of the sky speeds up and slows down necessarily as it goes from the Tropic of Capricorn to the Tropic of Cancer, then the translation of motion would correspondingly speed up and slow down. And wouldn't you know, interestingly, that's exactly what they measure with an alarming degree of specificity.
Yeah, so it was like it was essentially like a different way of measuring it, but getting the same results, right? I mean,
Yep.
it was
Yes.
significantly
Exactly.
different, right? Okay.
Yep. And then so that the last one that I covered, the Hector Monera guy that did the classic interferometers or Michelson setup that left it running for 3 years. That one, shoot, I just lost my train of thought in relation to what you said.
It was a different mode of.
I'm sorry. Yeah, sorry. It was super. The way that they did their apparatus, like more accurate and all that. They actually had some criticisms of Michelson Morley, of their setup, and they made their efforts to be even more accurate and have a better air tolerance and all that. And they measured the exact same fluctuations corresponding to what Miller measured, but the math framework that they used to interpret it, they used a different transformation equation set that allowed them to get a higher speed out of what would be needed for the contraction. So they said, so their claim is that they measured the speed around the speed of the sun going around the center of the galaxy or whatever. They say that they measured it at 320 kilometers a second or whatever, but they didn't, like, it's still the same measurement as the Michelson Morley.
So no matter what, the rotation of the Earth has never been measured terrestrially.
So the sidereal rotation of the sky has been measured in relation to whether or not it's the sun or the Earth or not. There hasn't been any direct measurements until Ruyong Wang in 2004, where the distinction made from his experiment is that the Earth is stationary with respect to an ether wind because of the rotational effects and how they were trying to explain the Sagnac effect to begin with. They would the natural interpretation of Wang's work is that the Earth is actually stationary with respect to an ether wind.
Oh wow! Thanks for clarifying that. That's amazing.
Yeah, because I
Right.
guess you could. Because I guess to be fair, you could interpret it either way. For the Sagnac, if there's not a linear explanation for it, you could very well go, okay, yeah, it's detecting Earth rotation, et cetera, et cetera. But yeah, in 2004, that was a huge change. Like that should have been. How people say, wouldn't
Nobel
you
Prize.
win? Yeah, wouldn't you win the Nobel Prize for disproving Einstein? Where's your published paper? Well, your boy Wang in 2004 did exactly that, and nobody's throwing a parade for that guy because of the fact of the implications of what that is. Because not only were they wrong a little bit, they were completely wrong about everything,
Right.
right? Like, so they can't, like, they're not going to overturn it
Well,
or do any mechanism for that.
it's like I said, dude. It's like the whole crux of the argument when they're like, "Haha, stupid flurps. We've measured Earth's rotation. Thanks, Bob, etc." All that nonsense. You're like, well, actually, we've linearized the Sagnac effect so it can specifically exclude, angular rotation as a cause of the interference pattern. So now, literally, all the arguments that we've had debating whether the measurement of motion is actually supposed Earth rotation or just a translation of motion from the sidereal rotation, all that's answered now and it's definitive and we're right. So I don't know, like I don't know how else to go forward.
Yeah, it's pretty cut and dry once you get a good understanding of what's going on, and it's like, oh, you know, it's like Modder Builder was saying the other night when he started looking into differentimetry. He was like, oh yeah, like that's crazy. It just
So that's over,
it,
right? You have no measurements of rotation of any kind. You have no motion of any kind. If the tenet of heliocentrism is Earth spinning and Earth's orbital velocity, you have failed to measure either now. Before there was just a bunch of nebulous, opaque crap where we could pick and choose. Well, actually, what are you measuring? You're saying it's Earth spin, but it coincides with the seasons, and you have to align it to the sky. But okay, yeah, so that's over. So now any measurements of motion of the sky, just we know that based on these measurements are actually measuring the translation of motion from the sidereal rotation. That's a fact. Literally all the globe is left.
yeah. Oh gee,
It's okay. It mostly wasn't for them, to be honest. It's to build the foundation upon which the flat Earth position should now be built. Like we shouldn't be in the camp of ignoring scientific measurements and the specificity of 5,200,000 experiment or measurements of this motion, right? Like we should embrace it as a position, and like we keep saying, the only two interpretations are stationary ether, moving Earth, moving ether, stationary Earth. Quite clearly, it's shown to be a moving ether and a stationary Earth over and over and over again.
amen, amen, brother, as they say in the South or wherever they say that. But yeah, um, it's really strong evidence for a stationary Earth with respect to a stationary or with respect to an ether wind. And using this as an argument takes away their bigger arguments and reveals the deception of special relativity, the relativistic framework, right? Because it's not, because this, the implication of it isn't just flat earth or rotating earth or whatever. They obfuscated, like they remade physics based on this interpretation so that they could continue a an endless mathematical framework labyrinth that our smartest men and women will just get lost in, thinking that they're coming up with all these, relativistic explanations that fit within the framework, and none of it's real. So it's very important to bring this argument to the forefront because it's just the implications are just it's literally it's in everything, man.
Right? Just to reflect quietly on how smart you thought you were when you thought you understood space time 10 years ago, watching a History Channel special or whatever the hell, but how the universe was made. Like,
Yeah, they literally just dazzled us and told us all this stuff and built it all and and put it all on Einstein and said that he was the one that came up with all this. And then you look at the history of the math and you see that it was all taken from other people, stitched together. He gives contradictory explanations to his own framework and his own postulates upon which his math is built upon. There's that incident with Paul Gerber where his equation is completely identical, and his explanation is that, oh,
yeah.
I've never seen Paul's work, so how could I have stolen his equation? Got you. Like, okay, dude, you literally said the same stuff about Lorentz, and in a private letter to your wife, who did most of your math, you're talking about how you're going to go study hard on Lorentz's ether theory and how his explanation to Michelson Morley, and then you and then your whole special relativity framework adheres to Lorentz covariance, but you don't cite them in your work. It's like there's a it's all made up.
That's
It's
like a
all
kid like getting caught eating a cookie with cookie all over his face, being like, "No, I didn't." I'm telling a bullshit lie. No, I didn't eat a cookie. And fuck you for
no,
asking.
our equations just look identical. Well, we came to the same conclusion based on different mechanisms. Like,
But
okay, dude. So for a second time in Einstein's career, boys, I'm gonna pull up the equation here in a second so we can all look at it. This for the second time in his career where his framework matches someone else's exact equations of an ether theory, because Gerber was an ether lad, and he set the propagation of the gravitational wave or whatever it was to be to match the speed of light or whatever through an ether mechanism. So that's what his math was. Then Einstein came along and changed two symbols, right? And didn't even change one that much, right? Like that's just a lowercase t, boys. So, or I'm sorry, that's just an uppercase t. And he's like, no, I didn't steal that equation. That's not. I've never seen his work. It's the same one. He did it again. And Gerber did that. He came up with his explanation 17 years before Einstein gave his equation to predict the perihelion precession.
Well, that's why we should get everyone to watch this wonderful, an hour-long video on the historicity of the fraudulency of Einstein. Was Einstein a fraud is
absolutely.
how it's framed, but it's like an hour of action-packed details of the actual of the history of all the things that he stole, how dumb he was when he said it, how all the actual critiquing scientific minds at the time literally tore it down, and then everything got obfuscated, hidden, and we were, raising him up to worship as a sky god.
Yep. Sky prophet.
Yeah, sky prophet. Yeah.
He predicted that a math equation would collapse in on itself, causing such a gravitational disturbance that it would curve space-time infinitely in perpetuity such that not even light could escape from it, and it would just infinitely eat everything that gets within a certain radius of it.
Yeah, everyone should go watch that one podcast. I think the guy who runs is kind of annoying, but the guest he has on is an absolute gem full of information.
Yeah, the history of it is crazy, man. And then when you look into how his wife was basically behind the scenes
Yep.
facilitating all the math, and then like he even says in his closing, uh, or like one of his last letters to her, because she's like, I'm about to go public and tell everybody what's up. Like I'm tired of being that secondhand, hand me down wife or whatever. And he's like, well, listen, if you tell everyone what's up, then you won't be like the prestige and everything won't be valid and you'll ruin everything anyway. So like don't do it. And then she didn't, she was like, oh yeah, I guess you're right. And then he was like, I'll give you the $50,000 from the what's it called? The Nobel Prize that he got. And he did. He gave her the 50K, paid her off. So
Well, that was a really good, really informative hour and a half.
yeah, dude, it seems like it was longer than that, but it's only been an hour and a half, huh?
A solid hour and a half. Jam-packed.
Solid. All right. Well, cool. I think we'll wrap up my YouTube stream then there. If nobody else has any questions, comments, or concerns.
Bravo, Alan. Bravo.
Thank you, sir.
Well done.
All right, Shane, I'm going to go ahead and cut off the tubes. Thank you, everyone, for coming out and watching the stream and or coming to the Discord and participating.
Nice. Nice and neat. And thanks, Gio. Thanks, everyone.
Yeah, thank you, Gio. Appreciate it, man. You're an awesome host. Thanks for everyone for listening in and, behaving and all that. Everyone being on their best behaves and all that.
I'm just going to choose to believe that everyone was blown back by the profundity of the information presented and the contextualizations of the context behind it, and that everyone was too awestruck to throw in any criticisms or contradictions.
Hell yeah. Hope so.
Yeah, cheers, guys. That was awesome. That was definitely jam packed. Yeah, it did feel like it went longer. Like that was only an hour and a half.
Yeah, I looked at my stream up or my recording up time, and I was like, "What? Only an hour and 29 minutes? How is this possible?"
Well, there was like no break in like mental focus. Like it took every word had to be because it was literally jam packed. Like there wasn't really any little downtimes or things like that. So yeah, that's awesome. Yeah, cheers.
Yeah, thank you.
Thank you.
Oh, look, now the Globers are coming back. Someone must have spread the word. Hey, Arma.
So I guess one thing I would bring up, like, Alan, what do you think it would take to replicate this? And what what tasks would you, or what would be like your list of things to go about in terms of like replicating and the like the top 5 tests that you would like to see replicated, and then any other thoughts you have on that part of it?
So single axis gyro readings at the equator and in the southern hemisphere would be awesome to see what they do, what the correction angles are, and what the readings they get. Because the readings they should get, it shouldn't matter about the device or the orientation or anything like that. There's a guy on YouTube that built a single axis gyro for about $600 in equipment and was able to get readings corresponding to his latitude that show quote unquote Earth rotation. So it shouldn't take much more than that. We, do readings there at the equator, and then we could map out the, what's going on with the direction of motion and how the mechanism of the ether, right? Like, is it, is it going faster in the southern hemisphere because of the angular momentum that would be required to, complete the rotation at that distance, further from the central axis? Is there some sort of mechanism that resets like at the equator or whatever? Is that, what kind of fluctuations do we get? And then so to reproduce Dayton Miller's work, the device sensitive enough to measure the 15 degrees per hour should be, like the device that guy has should be able to get the fluctuations needed. It should be sensitive enough to get that. But that's just me going off of not knowing at all. So, it seems pretty straightforward that there would be like an increase in the reading, right?
Yeah, and then at altitudes as well, and throughout the year during eclipses, it'd be awesome to see all those.
Oh yeah, especially during eclipses too, because you know how that affects the pendulum with the Elias effect. It would be interesting, to get it during eclipses as well.
How cool would it be to have them all going at once? You have like a pendulum, maybe 2-3 pendulums, a couple gyros, set it all up, man. It'd be cool to see that all done simultaneously and see what all the results are.
Man, I forgot about that, dude. The variance of the measurements at the same latitude at different altitude is a crusher for heliocentrism. There's no way that can be explained by a rotating sphere in any way. Like with the varying tangential speed at the same latitude wouldn't make any sense. So the fact that it does measure, and actually like Dayton Miller confirmed that it does vary at height. He's the one that says that aligns it to the sky, and the further closer to the sky you get, the better readings that you get. So like literally it changes as you go higher, and that's confirmed, and that is left out and overlooked and omitted more than all the rest of the stuff too.
Yep. I linked a video from a guy on YouTube that has a single axis gyro setup that he used. This guy's channel is pretty awesome too. He did a follow-up one where he made with a fiber optic cable that rotates. So he made like a classic Sagnac device that rotates as well, and got readings and all that. I think that device was like $600, and he was like selling printouts for that, but his website went down, and I haven't followed through to see if he still does that or is interested in it. Because for like $600, we would have a device that would be sensitive enough to at least get the rotational readings, maybe not sensitive enough to get the variation readings. But I would, if I had to bet on it, I would say that if it's sensitive enough to get the so-called rotational reading, that it would show the variation on the equinoxes.
Wow, you think that would do it? You think that'd be able to pick it up? Interesting.
I don't see why it wouldn't.
Yeah. You said that was only $600, you said?
Yeah, so he had a website was called skyhunter.com or something like that. It was on his YouTube, one of his descriptions. But yeah, you could order a laser printed. He would basically make it out of laser printed parts and or 3D printing or whatever that is. And then you assemble it or whatever, and it had like a little Bluetooth thing, so it would like you wouldn't even have to interfere with it to get the readings. It would just send all the data through Bluetooth and stuff. It was really nice. Here's the setup that he came up with for it, or one of them.
Nice. Yeah, I'm gonna check these out. 3D printed.
Yep. And here's his website. He's got some interesting papers and stuff and thoughts as well on all that. For those who are interested, he's like a really smart dude. He's he's got a bunch of patents and medical stuff and some other technology. And he has some papers published in an interferometry and ether and all that.
So with the name of that, is he saying it's a conspiracy of what we're told light is? Is that why it's called that, or?
Yeah, because he's an ether lad, but he believes in heliocentrism and all that.
Oh, okay.
And he's
Interesting.
but yeah, he has a nice collection of papers on like ether history and some stuff, his own thoughts on light and how it works and all that.
So it's like he knows there's issues with it, but so he's
Yeah.
So does he have like an ether wind on a spinning globe, or?
You know what? I don't know what he thinks specifically about his ether theories. The only papers I read of his were the one on the gyro, and he didn't get into the specifics of how he thought it worked in that. He's got this page here. And he's got a simulator too. So if you see, so here he's got a bunch of interferometer simulators. You can simulate various conditions, etc.
And then another question I had in terms of replicating it, do you think that the way the world is today, if it was replicated independently, do you think that a paper, or is this even something you would feel drawn to at all? But do you think something could be presented to the current, paradigm and those that are sort of in the authority positions to the point to where it could make a difference, or do you think do you think they'll be able to continue suppressing it even if replicated and shown?
There's such a stranglehold with the funding and the control mechanism for all this that the only way that there'll be a paradigm shift is if like the financial system collapses and everyone's like, all right, we got to reevaluate, similarly to what they did in the Soviet Union. What I found some interesting ether physics books and books that critique Einstein and his theories that we're not told about really in the West, and all this stuff came out of when the Soviet Union collapsed, and they were like, hey, let's re-examine everything from the ground up, and like they started pointing out all these contradictions in Einstein's theories and all that, and re-examining the history of the ether theories, and they were like, yeah, like it's obvious, that there's an ether, like why we even went down this road of pretending and all this. So it would take a complete collapse to remove the mechanism that's facilitating all this, right? Because if you're getting paid to make second order corrections and say that time dilation is the mechanism by which is affecting C, why would you go, no, don't pay me, I'm going to contradict that and take away everyone's money? Like, it's just, there's never going to happen.
Yeah, it's like the idea that they have like a backdoor deceptive implant that they're not just going to pull out and actually be like, all right, yeah, this, Yeah. But I see that perspective. But I mean, do you think with this particular equipment, anything could be done that they would not be able to ignore, in a sense, like something that would be even new or breakthrough within it.
No, they would just attribute it to instrumental error. They would say we're doing it wrong. We don't understand. They would reference modern interferometry done by so-called scientists that are doing it in basements and using materials and configurations that don't give readings that that correspond to any sort of motion, because they need no friend shift really to justify length contraction and all that. So like they have such a foothold and way to explain it that I don't think there's a way that we could do it or present it in a way that anyone would bat an eye, right? Because Dayton Miller, while he was alive, did it for 30 years, you know, and nobody could refute him while he was alive. You know, they waited till he died, and then you know was like, oh, this dude didn't know about temperature differences when he explicitly, you know, his life, you know, one could say his magnum opus to interferometry was explicitly figuring out what affects it in regards to temperature differentials. And you know, like that's just the kind of stuff that you'll get, and that's all it really takes to have people hand wave dismiss it, right? Because there's been independent mathematical analyses since these people, James Demio and Maurice Elias, doing independent analysis of Miller's data and the, you know, how it corresponds to the sidereal rotation and all that. And those guys found that there's like it's super strong evidence. Like they were like, yeah, this is crazy strong evidence, but but nobody, you know, just nobody cares. So I think it's just for us to like know this and figure it out and like move forward, and people can either like see what we're doing and like take an interest in it, or they can, you know, like I don't think there's going to be like a big pivotal one where it's like, you guys can't ignore this one. We did the thing, you know. Though there's always going to be a thing for them to fall back on.
Yeah, but it would be incredibly helpful for modeling. And
Oh, absolutely. Yeah, it'd be helpful for us. Yeah.
Yeah, and getting to the truth, and exactly. That's really what's important. Yeah, because I mean, this current system, that's a whole question in and of itself. You know, is there an idea to like, and everybody may have different ideas on this, like reform or shift what currently exists, or build something new, or some blend of those.
Yep. I think what they'll do is they'll establish a new framework of interpretation, and they'll say that it's mathematically covariant with relativity, and thereby linking it to covariance with Newton and linking it to covariance with Maxwell's equations. And even though they'll have a new description and a way to interpret, you know, etheric effects and things that directly contradict relativity, using new postulates and the mythology of covariance and the illusion that gives the credibility of the mathematics, they'll just sweep another one under the rug for everyone, because people are so thirsty for it to not give up space. Like I'm looking at all the history of all these interferometry interpretations, and like, you know, we have some of the smartest and brightest people, you know, figuring this stuff out and doing these charts and graphs and figuring out these friendship patterns, and they're like, but how do I transform it so that the speed equals 320 kilometers a second? You know, it's just like, oh, not a single one of them has like pumped the brakes on that and just looked at it for what it is, you know.
What do you think happens to interferometry going south? Like as you go further south, like even beyond the 60-degree parallel, what is your thoughts on what might happen?
So on a stationary non-rotating plane following a translation of motion of the sky, the readings would increase. It would the speed fluctuation would be faster. So the speed that they say relative to the latitude in the north, like that speed increase that they say at the 45th latitude, for example, I think that it would give a stronger reading. It would make the electromagnetic propagation faster in the 45th on the south, because to keep up with that momentum, you know, being away from the central axis of like the North Pole.
Yeah, exactly. Like spokes of a wheel, and how the outer part of the wheel is really cooking, whereas the inner part's kind of moving slower.
Exactly. And yeah, so like it wouldn't be like a crazy fluctuation amount where it's going to be like, oh my god, this is crazy. I turned my flashlight on and it works completely different, and like it would be like a small reading, but it would definitely be larger. It wouldn't be symmetrical to what it would have to be on a globe if it were to be attributed to the rotation of the globe and being axially aligned with that rotation.
Yeah, well, that would be incredible to see replicated, like
Yeah.
from like doing readings like from as far north as we can to as far south as we can, and get them at every latitude. Because like on the globe, of course, it should be symmetrical from the equator onward to the poles. So, what have you seen so far in terms of data for that? Like in terms of through the whole spectrum, because
Yeah.
that would
So,
be that's huge.
I could present real quick and show you something. 1 second.
Because I've seen ones that are spotty, but never like a full spectrum through it. Unless you've seen that, that'd be awesome to see at like every latitude.
So the only latitudes I've seen, should have the live stream up or whatever. If you want to join real quick, I can show you what I got.
I'll reshare it on the stream too for a sec. All right, it's up.
All right, so this lab right here,
We got a glob.
Italy,
We got a glob. We're starting out with a glob. All right.
Starting out with the glob.
We got a cartoon, and we shift to actually high altitude footage. Okay. And
All right, so here at this latitude, this is like the 43rd, right? And we have this observatory here at the similar. I think this one's at like the 46 or something like that. And then that guy in the YouTube video that I linked earlier is in Canada A. So he is, zoom out on the glob here. Can't find where I'm at. All right, so he was around the around here as well, around the 45th, in Canada A. So the orientation that they made for the corrections, the z-axis, they have it tilted 45 degrees. And they say that they're just aligning it with Polaris because that's the easiest way to align it with Earth's axis of rotation. And these are the only places that I've seen a single axis orientation alignment where they get the reading that's roughly when you take the reading and then you flip the device upside down, you invert it and take a separate reading, add it together and averages it out. That's where they're getting their 15 degrees per hour because it gives a reading of like 7.5 degrees, like what you would equate it to. So they take two readings and average it out. And that's where they say it matches 15 degrees per hour for the globe and all that. And then they don't have any readings, any stuff, going, further from that. And when Bob did his gyro observation, I think he was around like the 38th or 39th, somewhere in Colorado. So, and then again, you can't even actually analyze that gyroscope on that level because everything's goes through the Kalman data set and all that. So you just get whatever reading that they give you. So you can't really discern what sort of corrections would show up there from a single axis. But yeah, all of it was done in those latitudes where it would provide positive evidence for a globe if the effect were truly due to rotation and all that, right? Is that what your question was, by the way?
Yeah.
Okay.
Yeah,
Cool.
that definitely.
Gotcha.
That definitely is interesting. And then just what? Okay, so what about like? Because I've seen some of Dayton Miller's data as well, and he's got his spots as well. Like, if from all the data you've seen, like, how many latitudes do you think that like we could like that exist today of claims? Because like whether if it's connected to a globe, which I understand why they're trying to assert it that it is, because those gyros do have fringe shifts when they move, obviously, because that's why they use them in airplanes. XYZ axis movement will be recorded. So I understand why they're going to want to try to say that it has to do with Earth rotation, but there's so many more factors to it. I mean, the fact that it doesn't pick up the rotation of the orbit of the Earth around the sun is obviously a huge problem in and of itself, but even for them to try to claim that it's correlated to Earth rotation rather than the actual field rotation.
Yep. So those two labs at the north, by the way, Ginger Project. It's Ginger Snaps, Ginger Project. So this is part of the giant underground gyroscope relativity, something like that, or whatever. So that's where these two apparatuses are. So whatever, I think this one's at like the 46 or something latitude. Look here, actually, properties. So 43rd, and what was the Germany one? 49. So the 49th is the highest latitude I've seen the readings, and the lowest I've seen the readings would be Bob at 39, but that was using an inertial navigation system and not a single axis gyro. So for single axis gyros, it would have been somewhere in Canada around the 45th as well. So like literally only in the northern hemisphere between the 40th and 50th parallels is where all the globular evidence comes from.
Wow. And they got no pendulums at the equator too.
None, and that kind of gives it away in and of itself, right? Because like
Yeah.
when they were mapping out the stars and doing elevation correction angles to Polaris and building the map and all that stuff, they went to every latitude and were like, okay, it changes here. Okay, it changes here. Okay, it goes down another angle here. They did that for everything, and then for when it came to interferometry and measuring Earth rotation and all that, they were like, nope, we're just going to do it here, and it's some perfectly symmetrical everywhere uniformly. All right, guys, good night. It's like, what? Like, why didn't you? Why isn't there a thing where it's like somebody went every latitude and we get this reading here, we get this reading here, nothing. It's only in specific spots, or when they refer to a device that's basically classified that you can't analyze yourself, being an inertial navigation system, uh, where they make the bolsterous claim that this is evidence of heliocentrism and Earth rotation.
And then the South, it's like forget about it. Like in terms of
Yeah,
what's available, yeah, especially in the southern oceans as well.
yep,
Just that's totally uncharted as far as we know, right?
totally, totally uncharted. And then remember, with the inertial navigation systems, when you hit that, what is it? I think it was the 85th parallel. It changes into polar navigation mode, so you get an entirely different coordinate system up here for your inertial navigation systems. And then when you get to the south, and the same when you cross whatever parallel it is for the Antarctic Treaty, I think it's the 60th. So when you get to the 65th, it's when you get to that 66th, it switches to Antarctic navigation mode, and there's a different coordinate system used for that. And it's like, if you, so if that's the case and they have all that built in and that's just what they're telling us, well, if there's a discrepancy between these two areas and they need to hide something and you're using this system to navigate, well, when you get to these latitudes, the system will just automatically correct and change to the relevant coordinate system to make you think you're navigating on something and going in a certain direction and following a path of where there's nothing here in between this area. And you would never know because you're just following the inertial, navigation system, right? You know, and it's giving you these readings that are corresponding to a coordinate system, but they can just use a different one with the device, and you're not going to know the difference in the readings because the output you're getting is already corrected. So it's going to match whatever it needs to match to present globular evidence, right? Like they're not going to build a $20,000 inertial navigation system for someone to fuck around and prove the Earth's stationary, non-rotating, and all that, right? Like it's like, so that's why they have the common data set. The whole system is basically a supercomputer that compares its readings against the exact thing that I was talking about earlier. So how there's no public data where everyone went and took readings everywhere relative to the latitude. So the common data set that they use to compare the readings to as they're using their inertial navigation system is a data set constructed of such information of where readings were taken relative at every latitude at all distances, to build this, to make these systems so accurate, right? So, you know, just just but we don't have access to that, right? Like, so definitely proof of a globe, if you believe.
I'm not one for lore myself.
Not one for heliocentric mythology, dude. You know, I'm more of a Greek mythology man myself. I'm into Poseidon, Zeus,
That's as far as
Apollo.
fake.
Those guys are cool, but I'm not trying to fuck around with my boy Helios, you know?
Got the whole panthology to go through. I don't need to invent more.
So,
Yeah, I mean, but how difficult would it be to do then? I mean, if to have the device and just buy
so from that,
buy about 70 plane tickets and start
yeah, I mean,
pop around.
dude,
And
from that guy's setup, it looks very straightforward. It looks like something you could set up and assemble. Let me go through the video real quick. Still have it up.
yeah, the biggest expense would be the travel.
Yeah, like look at this thing. It's literally just a. See, where's this?
We just need to call the passport bros.
What about using Wang's linearized interferometer there?
Oh yeah, so you could do that with a just a fiber optic cable, right? You could do that as well. Yeah, I didn't even think about that because the implications. We don't even have to use an actual SAGNET device. We just need a fiber optic cable, really. Um, yeah, let me think about that then, because it actually makes it extremely easier.
There's also a lot of pilots in the community that maybe there could be someone who want if they have their own plane or they have access to a plane because to pop the different latitudes, if you could just have your own plane and then just slide into those smaller airports, that are easier, and that would
Yep.
be, or you could do ground travel too. But yeah, another option, of course, would be to have, if there was some like device that we could like mail people, then they could do it, or they could build it themselves. Of course, then that gets a little bit challenging because the ability to have like quality control is different if people are just doing the devices. Nonetheless, I mean, like we could get, yeah, it depends on what the cost is and what people in terms of their contributions. But I'm just saying that's another option too. Like one would be flying physically to those locations to get the readings. The other one would be to have multiple people that either have the ability to detect it and then report their results. You could even build like a larger thing where like people can actually upload the results to a database, and then the more that people are able to do, the better. And could also be like if some people really want to take it on, then they could do one, like each person goes to 5 latitudes in their region or something like that, even by car, or different things like that, where you could kind of, instead of one person doing it all. But yeah, those are all options. It'd be just incredible to see, like not only the different latitudes but the different longitudes as well.
Yeah. So what we would thinking about it now, so the effect should persist, like regardless of rotation and all that, right? Understanding that it's not just due to rotation. So we actually don't need that guy's rotational setup and all that. We would just need to figure out the cost of like a fiber optic cable that's sensitive enough to get that propagation in it, where we could measure it, and like the device necessary to measure at that sensitivity, because these are going to be really, really small readings. And with that, like literally, like Wang's conveyor belt situation was literally just a $5 million fiber optic cable wrapped around some spool, right? Like it wasn't even anything crazy. So we could just have a less expensive cable wrapped around a less expensive spool.
So do you guys think that the tests that have already been done, the millions of tests done by Dayton Miller, as well as the subsequent tests by Wang and others, are not sufficient enough? I mean, what
No,
is
it's
what is the opposing side's refutation of any of this information other than
so their refutation one is that that the effects are due to temperature differentials and it's some sort of instrumental error and it's not real. Second interpretation is that oh shit, I forget the second part of your question.
Well, I know we're talking about doing more
Oh, I'm sorry. The significance
tests.
for us would be so the correlation that they try and draw with it is that relative to the latitude, you're going to get a different amount of Earth rotation, and they say that this is measured by these devices. But the implication actually is that the Earth is stationary with respect to an ether wind relative to the latitude, and the speed fluctuation is the difference is the distance you are away from from the vortex. So it would help us model out the nature of the ether and of the plane, right? So if we're getting faster readings further away from it, that's like more or less confirmation that that there's an ether vortex over a plane, right? And that's
And that it goes out radially from the center instead of fitting uh, the symmetrical quality of a north and south hemisphere the way it would on a globe, perhaps as well. Like the
Yeah, so you're saying more tests need to be done basically more so in the southern hemisphere to test out the difference between the two models, meaning the symmetry on the GE model needs to be perfectly symmetrical. Right?
Yeah.
Oblately, it needs to be oblately symmetrical.
Yes, the slight deviation.
Good luck finding that oblateness within this.
But what would be super dope, is so how he's moving or measuring the translational speed fluctuation that corresponds to how the sun would have to change translational speed in the northern hemisphere and the southern hemisphere, respectively. What would be dope is if we had a northern hemisphere reading and a southern hemisphere reading going on at the same time, and the discrepancy was like matching up to the day, where it's like, hey, we got slower this day and we got faster this day. I mean, that would be just ridiculous.
Yeah, and then throughout the year as well, like that whole spectrum. Yeah, dude.
Yeah, that would be like, okay.
Yeah, this information, right? If we have the ability to run these tests at the different latitudes, especially in the south, would also be good to couple with what Witsit's been talking about regarding twilight times and things like that, right?
Yeah, because it's all facilitated on because the only scale, because like when you go back to the scale of interpretation for Michelson Morley, right? The scale that they came up for the fringe shift patterns to match heliocentrism was they said that each fringe represents 5 kilometers a second. Now, there's no actual metric of that measurement that they made, and they were like, "Oh yeah, when someone's moving at 5K, this is what it is." This is just their prediction, extrapolation, and scale that they came up with to interpret their readings, right? So the only thing that they've ever actually measured that fits within anything is a 15 degree per hour angular rotation in the northern hemisphere with those relative to those latitudes where they did Michelson-Gale and the Sagneck experiment, where they say that those are due to Earth rotation, and then they say relative to the latitude, blah blah blah. That's where they get all that from. So it should all. Kind of forgot where I was going with that, to be honest with you.
Yeah, all good. Shit. Do you hear that in the background?
Yeah.
My bad.
No, you're good. I didn't hear anything.
Okay.
Well, you're saying you got background noise? No, I didn't. It seems good.
I was washing out a filter in my vacuum, so I'm surprised it didn't pick it up.
Yeah, but what you were saying about the twilight as well. Yeah, so how much do you think interferometry changes in terms of the distance to the sun and then the ability to track the speed of the sun with it?
Well, I'm just saying, like, coupled with if we determine that the twilight is much smaller in the southern hemisphere in the times in which we would think that the sun would be down there, right?
Yeah. It's just
which would be the summertime, like that, coupled with the interferometry not being symmetrical as well, is almost like two final nails in the coffin, right? Like how could you explain away both of those ideas regarding the southern hemisphere that we've all just kind of been, I guess because not a lot of people live down there, everybody's just kind of assumed or not even thought about trying to take specific measurements that may be relative to a model that they never thought to question to begin with. Let me put it that way.
Hey, Wang's still alive, right?
Yeah.
So we could just call him up and say, hey, a bunch of people want to pay for his flight down there. Take his interferometer with him and just take some measurements, bro. That's all we want you to do. We'll pay for your flight.
Yeah. He stopped replying to my emails, so I don't think he's interested in that because he knows the implication of what he proved with the directional dependency of it. So like,
Fuck.
because when I emailed him asking about the ECI reference frame and all that, he stopped emailing me, and I couldn't figure out why. But it was the implication is that his work actually showed that it's that the stationary of that reference frame also applies to his linearization effect, and so the effect is with respect to an ether wind. So, and let's see here.
And from what I could imagine, when you were emailing him, you were asking him all the right questions to where he was like, "Okay,
Yeah, it was like
you're onto it." Yeah,
yeah.
I mean, do you think he knew? Do you think you brought anything new to him, or do you think he already knew it? Or that's interesting.
I think he already knew it because there's a guy that actually published a paper named Robert Bennett on his work, and he shows how the motion in which in the directional changing the direction of the device and stuff, how he created a lab frame, and the implication is that the effect is with a stationary Earth with respect to an ether wind. And so yeah, he probably doesn't like that because nobody wants to be the guy that just that like, hey, are you saying you're a flat earther or whatever, and all that? Because it's like falsifying relativity would be one thing, but then like they still adhere to like NASA and space and like those concepts. So like they couldn't completely be like they can't take it that far, so they just disregard. They're like, oh, you're interpreting my work wrong and all that kind of stuff. I would assume because yeah, when I emailed him and he said that he was happy to discuss his work and stuff with me, and I was like, cool, I'll hit you up after I study it some more and have some questions for you, and I can show you what I sent later. But yeah, it was basically just like, hey, so you're what kind of resistance have you met in academia because your work strongly contradicts special relativity, and just like what kind of resistance have you got in academia, like what's the general feel, and like how are things going with relativity and all that. And then the second question was in regards to the discrepancy in the two reference frames being the ECI frame and the ECEF frame. But the distinction there is that the ECI frame is stationary and the ECEF frame is the rotating frame. But the way that they show you the graphics for it in GIFs and stuff, it still shows Earth rotation, but a stationary coordinate system. So it was a little confusing to me, and I didn't quite get right away the implication of it. But yeah, when I asked him about that, he never replied, and it was like, okay, dude, cool. He knows that I know.
Yeah, and I would think like, how could he not have known?
Yeah.
Yeah. I mean, it's you can't do that and not know. But yeah, he could be. He could be. There's another possibility because they do trick a lot of these guys with relativistic physics, relativistic pseudophysics, in terms of using like reference frames to like detach physical reality and then just get someone to believe that you can have something stationary within something that's moving. Basically,
There's a tensor for that.
Yep.
Yeah, it's a couple calculations that get you there.
Yeah, man, it's crazy to see. Because there's another guy whose work I was looking into. His name is Stephen Gift, and he was saying like he completely acknowledged like the complete failure on relativity's part to explain these effects within the confines of what is it, Lorentz symmetry and all that, and without breaking covariance and all that. And he was like, but if we use a different transformation set of equations, we can maintain covariance. And it's like, buddy, it doesn't matter at this point. You had one shot to make covariance meaningful, and you guys all shit the bed, pardon my French. And now when you do it and, force covariance in under a certain arbitrary transformation, like nobody should care. Like, but they're like, no, but if I do it, like and people will accept it and this will be the thing. It's really interesting to see because it doesn't matter at all, and it has no meaning at this point. Like the relationship that covariance and what it like tries to establish with the mathematical framework, if you're just gonna beat everything into that framework and and then go, oh well, using these transformations and these ones, but same effect but different transformation. It's like nobody cares. That nobody should care at this point. Like you should see through it immediately. But they're super fixated on it because they want to be the one that saves, relativity or saves like the paradigm, right? So they try and they just try a different transformation. It's kind of sad because you can see how brilliant these guys are and how talented they are mathematically, and they're just trying to fit a nonsense coordinate system into explained physical phenomenon outside of the confines of the abstract math that is given to just to describe it in the first place.
Yeah, it's like a mathematical fracture.
Yeah. Their psyche's been fractured by math, dude. They just see the world in metric tensors and transformations.
Compartmentalized and disassociated.
Yep.
That's the training. It's the militaristic way. Yeah, this whole kind of current system. The way it's just like the coercion and repeat kind of structures. And like, I almost think about it as like, it's like they're like throwing people Rubik's cubes and the people are, I don't even know if that's the best analogy, but it just makes me feel like they're like, they have their hands tied up with like this. I'm just kind of imagining this almost like the thing of doing a Rubik's cube where you just have your mind, like you're just looking down and just trying to solve this little thing, instead of like actually being like a free being that's actually taking all the information in and being willing to go where the actual evidence and the results actually take you to the full extent without blockages and axioms and foundations that are faulty and based on assumptions.
Yeah. Yep. But if you're paid to do it, I mean, why would you stop, right? You
And
get
then there's
special,
that, yeah.
you get special accolades and that stuff for adhering to it and believing it the hardest. You get little rewards.
Yeah, you get a jet ski for some weekend time at the lake.
Yeah.
Whatever it may be. I mean, yeah, if they're because some of those guys in the kind of certain of these fields, especially the ones at the top of the fields, then yeah, I mean they're whatever. I mean, they're probably some of them might have a lot of wealth actually, but there's a lot that are probably making like closer to like maybe what like lawyers and doctors make, to the point to where like those sort of added little like luxuries that bigger house, multiple cars, whatever it may be. So yeah, and then if your whole income stream and your all of your education and all of the money that someone spent to go to school to get the degrees, all of it, and they're hired by someone that has those fundamental axioms built into it, then for them to go against it, like boom, they're out of a job pretty much instantly. It would seem, or like be the case, unless the whole industry is going to be like, all right, yeah, no, let's actually look at what this guy has. Like that's what it would be if it was legit, but it just, I don't think it is. It's corrupt and it's like a group think kind of cult almost.
Yeah, I like the example of Lewis Essen, who made the atomic clock. When he was a proponent of the relativistic theory, and he taught it for many years. He was a great man. Everyone loved him. Super smart. Oh my God, he's a genius. And then later, when he retired and started looking at the paradoxical nature of what he was teaching was built upon, and his understanding of the atomic clock and how it works, because the guy that invented the thing probably knows how it works at least, right? Everyone turned on him and calls him a crackpot, and he doesn't know what he's talking about, and all this and that. And it's like he started pointing out like the fallaciousness of time dilation and the clock paradox, the twin paradox, and all that, and how a atomic clock can't be used to determine relativistic effects and all that. And they completely, just discredit him and act like he, lost his mind at the end of his career or something, when it's like he clearly gained the most clarity he'd ever had in his life, So, just it is what it is. Like they circle the wagons for relativity, man, because they so much as like hinges on it. They literally can't. they can't even imagine that they were wrong. You know, like if your whole world that you're taught is like math is reality, and you have this romantic relationship with the equations or whatever, your profound understanding of them, uh, you're gonna interpret everything through that lens, and you're gonna try and model yourself after being like the smartest people, and like the smartest people used Einstein's equations and Einstein's framework. So you're gonna do the same thing, and like deviating from that's gonna be crazy. Would be career suicide.
Yeah. It'd be like if a doctor just stood up against big pharma. It's like, all right, well, all of his student loans and all his, 4 to
Right.
5, 6 years of education, all of their internships and residencies and years of building up to all of that. Yeah, that's huge. That's like pulling the entire rug of out from under them of pretty much their whole life. Up to that point. I mean, the major thrust of their life, if that's their full profession and everything. And then what's intense about it too, though, is that even if someone were to do that and say, all right, fine, all right, I'm done with that job. I'm sticking with the truth. But then where's all the money to support what would be needed so that he could even make a living in actually, doing things that are going to actually progress things forward, that are not just part of the kind of the current machine, as it were.
Yeah.
So
Yeah,
yeah,
absolutely.
it's
It's a
multi-layered.
tough pickle. It's a
Yeah.
tough pickle, man. And then a majority of the population thinks that scientists go to work every day trying to disprove one another and like, cancel out their biases and be objective and not follow the funding and stuff. And it's like completely the opposite. So when these interpretations are presented that correspond with, and reify the current theory of interpretation, no one really bats an eye, and they're just like, "Oh, cool, relativity got verified again through another experiment." And it's like, you don't even have to like look at the underlying mechanisms of the experiment. You just have to repeat the accuracy in which relativity has been verified to infinity, you know, and you're good to go. Like that's how little I think that it matters, right? Because if it mattered, people's understanding of it would be proportional to that, right? Like if relativity theory and relativistic effects meant anything, people would be like, "Oh, watch out for that. You don't want to go, you don't want to swim after you eat. Like time dilation will get you." Like like more people would know things about it, right? It wouldn't just be abstract math that only corresponds to explanations of things in the sky and effects of light, really minuscule effects on light. So it's just super compartmentalized.
Yeah, but if some of them were confronted with like data that showed like the interferometry readings in the north at the equator in the south that don't fit a rotating sphere, like do you think they would? I mean, it seems like they would have to turn their heads at that.
Yeah. So if we had the data corresponding to the south and that, and closer to the poles and whatnot, like yeah, that would definitely raise some eyebrows, because you couldn't ignore that, like because it would have to be pretty much symmetrical on the globe, oblate or not, right?
Yeah, unless they're going to come up with some, southern magnetic field refraction or some, I don't,
Yeah,
some
yeah,
relativistic physics that just inverts and fabricates some concept or something. But still, I mean, yeah, the whole claim is that it's due to Earth rotation. So why would if the whole thing is rotating, then it would seem, unless maybe some wild concept that they might try to come up with, like, but it doesn't seem like that would pass, especially if the readings were detailed. And then to have like the Elias effect as well, like what it does during eclipses, and then also to have more of the altitude ones, like to have like these readings at different altitudes and different latitudes and longitudes around the world is really what would be incredible to see, because then we could see like that whole system. And if that's showing more of a radial effect going out from the center and then just expanding as you go south versus with the oblateness of a spheroid, that of a globe, the oblate spheroid globe type idea, it would have to be symmetrical in alignment with that oblateness, you would think. So that could be matched to the WGS 84. So if we had all these readings, we could see, okay, does it fit the WGS 84? Yes or no. If it does, then okay, that actually is quite, that's would be pushing that, that's what that would show. But and then if it doesn't, then it's like, yeah, the WGS 84 is out at that point, as even being an option. So
Yep. Absolutely.
You guys are amazing. Thank you.
You're welcome, bro. You're amazing too.
So couldn't this like eventually lead to like a lot of, I mean, this is what leads to big breakthroughs in technology, right? That would be a pretty big paradigm shift. That would be hard to dispute.
Yeah. But they've think about this, right? So the accuracy of GPS is entirely dependent on these effects, and look at how well they've obfuscated that from everyone. People actively say that GPS is proof that Einstein's theories are true and all this stuff, and it's like literally the like how it actually works directly contradicts it on every level. It's like, so it's going to be a tough hurdle to overcome.
be also interesting to see if there's like variations in the interferometry readings in the same places that there are claimed to be like gravitational anomalies, and be interesting to see if there's any correlation between that, like the interferometry and the gravitational anomaly areas.
I'm sorry, say that again.
Well, there's claims apparently that, around the Earth in different areas, there's like gravitational anomalous areas where like the 9.8 meters per second is not 9.8 meters per second. Like it changes and varies in certain areas. And I was saying it'd be interesting to see like interferometry readings in those areas to see if there's a correlation between those gravitational anomaly areas and the interferometry readings.
Yeah, yeah, it would. In the gravimeter, they actually use interferometry to measure that discrepancy too. But I don't think that the light reading itself is affected by that. As far as I know, there's no experiment that shows a relationship where there's like any sort of gravitational effect affecting light. Because like they try and they say through relativity theory they describe gravity as a gravitational field. Um, And the experiments that they've done, so Pound Repka and Pound Snyder, and what's the other one, the atomic clock one, the Heffel and Keating, all of these experiments were trying to establish a cause and effect relationship with the change in light versus its interaction with a so-called gravitational field. And every single one of the experiments was an actual null result for that. But people talk about the experiments as if they proved relativity and all that, but in the papers themselves, they explicitly say that they couldn't differentiate between classical mechanic effects and relativistic effects. So, I don't think there would be any discrepancies in that regard. You know what I mean? I think it would be more relative to where your position or location relative to the center of the ether vortex.
Yeah. But could there be like fluctuations within, like, do you think the ether wind is just one consistent thing, or do you think it has like a fluctuations or pulsations within it, or even areas that are of different values, like
Yeah,
local vortices that have slightly different rotational or field effects compared to how those local vortices fit into the larger vortice?
So personally, I think it's a uniform motion, all going east to west in one direction. It's not pulsating. I think it's a consistent speed relative to the latitude. And I think that that's kind of how they got away with, saying that these are globular effects relative to the latitude, and especially using the northern hemisphere to attribute the effects and then hiding the southern. So I think it works in that regard that it's just a uniform motion that gets faster as you get further away from the center of the vortex. I don't think there's like pockets of speed fluctuations in it. I mean, there could be, but I don't think that there are.
Yeah, I mean the sidereal rotation is quite consistent, even though there are
Mhm.
the wandering stars and all of that. But yeah, like the
Mhm.
way the sun moves and the way the stars move. So it does see, like, in terms of that rotation, it does seem like a consistent sort of sweeping rotation, and it does have that kind of clockwork like quality to it in
Yeah.
terms of that. Just be interesting though to see at different latitude or altitudes as well. But there could be other things that would affect it as well. There could be other factors of the environment at different altitudes, and what do you think the pressure effect is on it at different altitudes?
I don't think it affects it. Yeah, I don't think it would affect it. Maybe in regards to uh, the propagation speed in terms of the refractive index, right? So if you're at like a higher latitude, like maybe there's less water vapor or whatever kind of thing, less air molecules, maybe in that regard.
Yeah. What about like well, it'd be interesting that you could actually
Well, they do them in vacuums too,
yeah,
so
that's what I
yeah,
was gonna say.
I don't think it would affect it at all. Yeah,
Oh, to do it at like different pressures that you could simulate as well would be interesting to see, like simulating different environments, like
yeah.
partial vacuums. I mean, what is, like, did they bring that to Dayton Miller in terms of at when he was doing it at altitude? Like, did he control for that, like the pressure effects or like the barometric pressure differences?
No, he used an open device for it. He so no, he would do. Sometimes he would have like cardboard tubes for the light beam, to like enclose it. And other times he would just do it open raw dog. He didn't take any consideration for that, like in the way that you're thinking.
That sounds kinky as hell.
Yeah, I mean, wouldn't it on a globe too, at altitude? Like, shouldn't it be symmetrical and it should show like an additional spherical vector at altitude? That would be because you're like further from the center. Like, shouldn't it actually show like a different arc if it was a globe? And
I would
Hey,
say,
that would also be symmetrical at latitude and altitude.
yeah, I would say that it would have to be symmetrical with the ground reading, because what would be the mechanism to translate the motion as it gets further away from it in the relativistic paradigm, right? There wouldn't be one. So, and if they say like, the atmosphere or whatever is in lockstep with the rotation of the Earth. So if that were the case, then they couldn't get a difference in the reading.
Well, I'm just thinking, yeah, no, I know what you mean by that with the way that they have their atmosphere and the gravity components of it. That's all kind of moving it along with it, is what they try to go with. But if you go to a higher altitude on a globe, wouldn't it be further from the center? So your radius value would be greater. And then that motion, I mean, that would be such a minimal effect. It would not be the same effect. Sounds like what Dayton Miller got was significant. What I'm referring to is I'm referring to like a very, very minor difference that would fit the fact that instead of being like 39.59 from the radius as on the ground, maybe you're, a couple thousand extra feet or even 10,000 feet more than.
No, I see. Yeah, I see what you're saying. But yeah, they explicitly say that doesn't happen that way. But yeah,
like
you would think it would though, based on like that logic, right? Because it would be based on the angular rotation at the equator at 1,000 miles to fit the 15 degrees per hour, right? So it absolutely, and that's radius is based on the what is it? The inward fucking location of the glob, right? So yeah, it would just be extending the radius essentially, right? You would expect it to do that. Yeah, but they explicitly say it doesn't.
Interesting. Well, I mean, it seems like they would have to admit that it would be at least somewhat. But yeah, I mean, if you're like how many miles above the Earth can you realistically be? Even at the highest altitude, it's really only a couple miles. Of course, if you did it like in some kind of hot airship or hot air balloon or something at really high altitudes, that's a different thing. But
dude, could you imagine in an airship, bro? What could be done in a blimp, man? Like, oh my god!
I know
the fact that they won't let us have airships, guys. Like that should just red flag. We can't have airships.
You know what would be the nerdiest?
Yeah, for real. I know what happened to the airships. Yeah,
airships.
The the free energy hydrogen fueled airships. You could float for as long as you want, freely making hydrogen and propelling yourself just in a pod in the sky, just cruising. You go anywhere on Earth.
God, well, can you imagine? You can't put a meter on it. Duh.
Shit, bros.
Use your electrostatic tether tech to be able to go up and down,
dude.
right? So you can navigate accordingly.
Oh, dude, this dude's sailing the ether winds, bro. Yeah, man. It like that's stuff like that is like a dead giveaway because this is all stuff that they would be doing to be like, hey, this is once we realized this globe proof, we took it to the extreme and really solidified it, and then have all these measurements based on it.
Dude, if it was real, we'd be in space right now, sitting, chilling out there. There would already be like, well, I'm joking that we'd be there, but I'm just saying there would already be all kinds of civilian stuff going on there. It would be one of the biggest sectors on Earth right now, I think, if it was real. But it's like weird and locked down and like only run through these government channels, and it's crazy. And then they give us CGI and just garbage imagery.
Dude, and have you ever looked into the funding for SpaceX? Their biggest investors are NASA.
Yeah, dude, somebody came in here and we were talking about it one day, and dude, I was looking up and I was like reading the actual. Yeah, they got like it says, I mean, as far as Wikipedia and that history, at one point, like they were completely bankrupt, and NASA literally saved them with this like grant, and it was like this grant that like has only been given to them. It was like massive amount of money and basically recharged the whole company. And right when that happened is when Elon Musk like gave over all of his mission control to NASA. So whether they were in on it in the first place, either way, NASA just basically funded and subsumed, virtually all of it, like in terms of the funding of it.
Yeah, dude. And I don't know.
Yeah, the Earth hopped around and.
What?
Yeah, and I don't even think Elon was in on it on that level necessarily, because if you watch that video or the movie that was out recently, that little documentary or whatever about his mission to Mars and all that. When he like literally thought, he was like, yeah, I'm going to invest in space and go in there. It's going to be dope. And then NASA and all his like heroes and everything turned around and was like, no, it's too dangerous. You can't go. Don't do it. You're not allowed. He was like, what?
All right.
It was very heartbreaking.
I got a plan. Ruyong Wang's University is St. Cloud, Minnesota.
Mm-hmm.
What we do, we're going to get together. We're going to steal his interferometer and we're going to fly it down to I'm just coming up with an idea.
Yeah,
Throwing it out there. We just go get that
speculating.
interferometer.
Yeah.
That was a joke for joke purposes only. Yeah, no, what? But it seems like we'd probably have to do it ourselves. It seems. I'm not sure anyone's gonna take the quest with us. When I say anyone, meaning someone who's already plugged into the mainstream paradigm. It would be hard for me to think that they would want to, unless they're ready for what the consequences are, or what the results would be, and whether they'd have to, what they would have to actually maintain in terms of the results of it. But
yeah.
It is kind of weird that all the guys doing these experiments were all, globers. I mean, they couldn't, see the bigger picture.
Well, they all adhere to, and this is the Royal Society members, right? Because when you look back at these old experiments, these are all Royal Society members, Royal Astronomical Society members, esquires and stuff to the king and stuff. So they're all beholden to the people that are funding their societies and whatnot and their institutions. So, yeah, when you're beholden to that Copernican principle and Kepler's laws and all that kind of stuff, your framework is always going to be through that lens. Like, you're not going to question it. Like, even how they frame it now, the Michelson Morley experiment, is they act like Earth's motion was just never even in question. Like, it's just assumed. And then when it was directly not measured, like, the implication wasn't there's they don't tell you this in Wikipedia. They try and do it one-sidedly. They say that the implication is that there's no ether. But the other implication is that the Earth is at rest with respect to a moving ether, right? And they won't tell you that because they need it to be very one-sided.
Checks like every leg kick, isn't that crazy, chap? 1-800 offer to your home. Good.
Yeah, man, that is yeah, why are they so opposed? Well, I guess it's just the Copernican principle, like you said, it really is an adherence to that, because that established the Earth is moving, and and then relativity and everything that goes with it. Yeah, it's like the house of cards. This is like the card at the very bottom that if you pull it, the whole thing's coming down.
Yeah.
There's no other option. So there might be other cards that you could pull and the whole thing won't come down, you'll be all right. Or maybe you'll lose a little section or lose
exactly.
But this one's just, it's a key support.
Exactly, man. This is why it was the biggest experiment in physics. This is why, it required such attention, such an explanation, because the implications are that they were wrong about their entire model of cosmology and everything that they had been perpetuating and everything that they had been telling everybody for centuries was, we look at the sky and we make triangles, or we don't make triangles, depending on how you want to interpret a celestial triangle. And we know these distances, and the Earth is spinning at this speed, and the elegance of the motion of Earth is the only thing that can explain these, observations and a cohesive model. And just trust us, guys. And they finally had a chance to measure that relative motion, right? Because that's the whole mechanism of what the ether would provide, a variance in the speed of light relative to the motion of that ether. And they found a pattern that didn't go along with what they needed. And they were just like, oh, snap. What do we do, boys?
Instrumental error, bury the guys that are continuing to do it, and run us right into World War II. And then from there, we'll establish, NASA, bring the Nazi war criminals over to create NASA, get a little rocket science going, get a little fake moon landing going, show the picture of the glob, and that's it. Just leave all that behind. Yeah, that's what they
reuse the rocket, or the Nazi rocket propaganda videos from the V-twin or whatever it's called rocket. Where they say that the first picture of Earth curvature was taken from Werner von Braun's rocket. and then they just reuse that exact same picture. You can line it up with the one that they used in whatever time later, after we co-opted your boy Warner von Braun. And then so the picture that they show later on was like the exact same curvature, altitude, etc. And this was supposed to be from a different device, different altitude and all that, and it's like literally the exact same. So it's like, very cool that they did all that. And this
I've
is
seen
what
that,
helps them do
yeah.
it.
And this is what?
Oh yeah, and this is the mathematical framework that helps keep that and keeps people from realizing that we're not moving.
Yeah.
All motion's relative, man, and all that.
Yeah. Wow. It's like just the right factors that they were able, and all. Yeah, it does seem quite of a concocted agenda. Where there's clearly like an intelligent drive behind it. I'm not really calling them intelligent, but I mean they're definitely like clever psychopaths. It seems so. The ones at the kind of top, as it were, that have kind of pulled that off. I mean, it's a little surprising that people bought it all, but it was a long process that took a long time, and a couple of world wars and everything that happened to where we're able to get it to that point. But
yeah, they just had to break humanity and then give them hope and something to believe in with abstract math in the sky. And used the story of Einstein being a Jew and coming from Germany, and this new healing factor that could be facilitated through that. Because if you read Eddington's memoirs and stuff, a big thing for him was wanting to use. Hold on one second. Sorry, I had to cough real quick. A big thing for Eddington was that he wanted to use Einstein and this Jew and German relationship paradigm as like a healing factor for the world to bring people together and show that a British guy would look at a Jewish German math work and then and verify his experiment and or his math, and everything would just kind of bring everything together. Like that was a super important thing for him that he talks about, that he's very proud of. So yeah, absolutely, man. When everyone was battle fatigued and worn out and had nothing to, just like the absolute worst thing in humanity had just occurred, and all that loss of life and everything. And yeah, they suddenly Einstein was this the catalyst for healing.
wow, that's deep, dude.
Yeah.
Hello. How you doing, guys?
They brought in their.
Just woke up and
they tried to bring in a savior. Hey, what's up?
Yep.
I wanted to bring out thing into the conversation regarding the movement of the Earth. One thing is that they say that they are different coordinate systems or different spaces or different what you want to frame of references, because they say that first we move around ourselves, then we move around the sun, then we move this. The sun is moving towards somewhere, and the galaxy, the planets and the sun is moving one direction. Oh, sorry, I said that already. So our galaxy is moving. The Milky Way galaxy, which we are part of, that is moving in one direction, and also the group of galaxies. So it's very big. So we don't understand that, but that is moving very fast, like millions of kilometers per hour in some direction. And at the same time, the space is expanding, so to speak. But it's wonder when you ask them, okay, if the space is expanding from the Big Bang, of course, is it expanding, for example, here where I live? Like, is the space between me and some tree or some other person expanding here? They say no, of course it's happening only in a larger scale. So then they bring the scale, so the space expansion happens only in larger scale, which doesn't make any sense. But that's just one fairy tale. But my final point in this is that they are bringing multiple spaces, multiple coordinate system X, Y, Z in our head. Like, okay, you have to. That's why we don't see any movement, because it's a relative to the position where we are.
Yep.
But but I believe, and it's kind of fact or something you cannot prove wrong, that there is only one X, Y, Z coordinate system in whatever we are living. There cannot be multiple of those. That's impossibility.
Well, it's just a coordinate system description, right? Like other coordinate systems could exist, right? But there's the thing with there being an absolute coordinate system, right? An absolute reference frame, which is what Einstein's theory is built upon, saying doesn't exist mathematically or physically, is that is what allows this idea that all motion is relative to some other reference frame, right?
Yeah, exactly. But in a real world where we are living, there is only one coordinate system. There cannot be multiple of those. Who is deciding what?
Yeah, I see what you're saying. Yeah.
But the point is, okay. The second thing is that they say we are moving in multiple directions, like 6 different directions at the same time.
Yeah.
Yeah, but the thing is that one particle, one thing, can move in only one direction at time in this coordinate system. It cannot move at the same time multiple directions. Of course, when the time changes, we go forward in time, then the direction or the speed can change, yes. But when we take a slice of time, there is only one vector pointing in one direction of every single object that there is, like whatever, it's a butterfly or an airplane or whatever it is. It can only, if we take a still shot of that and add a vector of the movement direction in there, still shot, imaginary of course, it can only point in one direction. And in their model, it should be like 6 different vectors pointing 6 different speeds in 6 different directions, which is impossible, of course.
Yeah, Alan, that's really, dude, if it was the globe and the interferometry, it would be wild, bro. Because, yeah, what he's saying as well, like, you think about being able to pick all that up, you know, and like now you get into like the math of like what level interferometry should pick up. It definitely should be picking up the Earth around the sun. Like, it's, you know, that's for sure. But like, I was just thinking, like doing it at different latitudes, like with what he was saying as well, because everyone would have a different combination of all those vectors. Because if you're if even with the Earth just going around the sun, just that one, you're rotating on it, but the globe is tilted and you're in that elliptical orbit. So whatever part of the latitude and longitude of the globe you're on, and whatever part of the tilt has to be taken into the vector of rotating around the Earth. So like, not only should that be picked up, but it should be picked up in all the spectrums at all the latitudes, fitting a globe. If their explanation was true.
No, you're absolutely right. It should, dude. It should vary wildly. It shouldn't be even as consistent as it is. So that actually adds credence to a uniform motion of the ether wind, because that would be the only mechanism to explain how it's relative to the latitude as it gets further away from the vortex.
Exactly, in a stationary framework with a consistency of the field. Yeah, exactly. The field.
Absolutely, effect. Dude. Yeah, totally. Totally forgot about that.
And then the altitude would show, again, if it was the globe, you would have like everything I just said there, even and then you add an altitude, not just latitude, longitude, and the tilt of the globe, but also the altitude you're at. That would even be in there as well. And what we, over a planar surface, getting a different altitude, again, if there's a consistency there where you have the east to west, but then you also have the altitude component as well, then that's showing that you have the like XYZ axis within a stationary system of a consistent movement, which of course FX is connected to the stars, doesn't really take anything other than just being directly informed with logic, which is that when that fits that uniform motion of the stars, then it's a uniform movement within a stationary foundation.
How dare you? No, that's exactly it, man. That's the implication. That's what they can't have. That's why Wang's paper wasn't blown up and nobody cares and people ignore it. And, because like if you don't look, you don't have to know about it. You know, you could just blindly believe in all the vectors of motion that don't exist that would clearly have to be measured. So think about that guy that was saying that proposed so in GPS, how he was saying that maybe there's a local ether that only surrounds like the Earth's atmosphere, and that's why we don't have to account for the orbital velocity, and it's just the rotational factor because they try and account the Sagnac effect to that uniform motion or whatever discrepancy relative to the latitude. And he was like, well, maybe there's like a local ether, and that would like that's why they have to describe it that way because you would absolutely all the if that's how the mechanism works, right? Where it's relative to the ether or the velocity of light is relative to the or delay is proportional to the velocity of motion of the observer, right? So if the Earth's in motion at 5 different vectors, all of that motion is going to be added up, and that's going to show up in the interferometry. And as the Earth is also rotating on its axis, like you were saying, as it's lining up and not aligning with these different axes or vectors of motion, the readings are going to change, and that would absolutely be shown or reflected in GPS and what Wang showed, but it doesn't. So yeah, that's a really important thing to note.
Yeah, I'm surprised we don't have any ballers in here saying, "Oh no, it works exactly like this. This is how we know that what you're saying is bullshit." There's no ballers in here saying that right now. I wonder why. They're just in the chat.
Are you familiar? Are you familiar with the Professor Dave YouTube channel?
I've heard of it.
Professor Dave.
Professor Dave.
I just
Not a Professor Dave.
Yeah, I know. That's why I'm a fake professor and publicly because he's a fake as well. But the point is, I watched his movie. There were Dirt or the Deep Inside the Rabbit Hole. The
straw man.
Anyway, he was interviewed there, but in the very beginning they were discussing the gravity, and Dave was asked about the gravity, and he replied, as it is like it's a bending of the space-time. And it was very interesting. He said that because we see round planets, massive planets gathered together by the gravity, which is the bending of the space-time. Therefore, the bending of the space-time is the reason for these massive planets to be formed. So that's a so deep circular reasoning or a clear circular reasoning. It's kind of apple is made of apple tree because it's hanging in the apple tree. It's kind of the circular reasoning that's saying that, okay, because we believe there is a space-time bending, and that bending is causing the planets to be happened, we can prove that by looking those objects are the shape they are. And he didn't know that he was I don't know if you know what a circular reasoning is, but when talking these issues, you should have the basic knowledge what is a circular reasoning. But yeah, that was very interesting starting point at the 2 minutes on the video. That okay, he didn't know that he just blindly repeats something without understanding. That's not an explanation. That's kind of
Yeah, that's how
make
they
me
get
angry.
us all, bro. Yeah, that's how they get us all, bro. You just teach the masses like short phrases and circular logic, stuff, and they just repeat it and they're good to go. Like I used to say
But
the same stuff about gravity and space time.
okay, it seems he I don't know. Maybe the Professor Dave is just evil by his nature. Oh, then he doesn't understand what he's talking. He's just learned things like he can repeat them. Yeah, very good. He's very good repeating things. But I'm not sure if he has an kind of any kind of thoughts put
Understanding.
into those.
Yeah,
Understanding
does he
what he's
really
talking.
understand?
Yeah.
He really understand. Yeah, well, he can't. Well, no one can. That's what's so interesting about this conversation, about this particular conversation, but the whole subject. Because how long is it going to take before there's enough people with common sense that are actually applying, the application of the common sense to the arguments to make it actually make sense rather than just repeating what we're supposed to say. Like how many people does it take to like realize it's just fallacious on its face in so many ways and impossible, literally impossible. When you talk about dynamics not even being involved with their model, the dynamics aren't even applied. It's just geometry and kinematics. So
Yeah. But it makes me kind of sad because these people like represent themselves as very clever and understanding and wise people in the front of the majority of so-called normal people who doesn't dig deep into these things. But like, for example, I digged a little deep in some areas of flat earth and I know something about those. So when somebody's lying so clearly about something, it makes me angry. Like, don't you understand, or are you lying because you want to just lie?
Right. That's why it makes it interesting. Like we still don't know. Like I was going to say earlier when I was listening to you talk about the Michelson Morley experiment being implemented. They were expecting certain results because maybe the guys at the top of their field that were doing the test, they might have actually believed that we go around the sun. At least it makes it seem that.
Your mic's going out. Your mic went out. You were good, but then it went out.
You would think that they would know.
Yeah, you're good.
No, Mike?
Yeah, you're good now.
You would think they would know. You would think that they would know how fallacious it is. And it was almost like a sabotage. Like, oh, okay, so you think we're going around the sun? Well, let's do this test that'll prove if we're going around the sun or not through the ether. And maybe the results were like a sabotage, but kind of like a hidden one. And then the reaction to it was, I mean, you have to think about like at the time when the people that knew we weren't going around the sun, was there any kind of like, did they try to block the experiment from ever even taking place? Because they knew what it would show. Those kind of things. Because, I mean, it has to be like we've talked about this, Gio. Like, did they know? Or did they really believe we were going around the sun? Were they really that brainwashed themselves?
Dude, they hardcore believed it, bro. Dayton Miller made a model of a globe tilted at different angles relative to a stationary sun, dog. Like, they 100% believed
crazy.
it.
You know what I'm saying? Even in the face of the results, they're still making excuses for it.
Yeah. You know what's crazy, man, is I asked a Glober one time who's like, who knows, like, he's in academia and he knows all the flat earth arguments and whatnot. And I was asking him about how one could measure the speed change in, in Earth's elliptical orbit, right? Because they say that, it's traveling at a constant speed, but then it's also changing speed. And, the change of speed would kill everyone, but they say it's just slight change and, all that stuff or whatever, right? So I was asking them, like, how, like, is there a way to measure that? They're like, no, the way to measure it doesn't exist and all that. And it's like, that's literally what Dayton Miller's work was. He thought that he was measuring that, but just at a way slower speed. And they wouldn't take it because they had already moved on from it because they couldn't go back on the ether or like on removing it,
Well, that's what's interesting about it because it's like, okay, so they obviously had to get rid of the ether because it debunked the heliocentric model, basically. It is the card that takes all the cards down. So there must have been some people that realized this wasn't the case beforehand, right? Like some of the people.
Yeah, absolutely. Yeah. So That's what I was saying earlier. Like those guys that are in these royal societies and stuff, like they're beholden to their secret society dogma and lore and literature and all that. And so, if they're like, "Hey, we're doing these science experiments, and the Earth's in motion and all that stuff," and he's like, "Hey, we got an experiment where it could easily be interpreted that the Earth isn't in motion," and they're like, "Okay, so like let's never talk about that because our entire worldview is that the earth is in motion and stuff, so let's only discuss it in a way that paints it in this light." And that's why they went with it, right? And then Einstein's with his framework and like the interpretation that he put forward, literally the exact same framework as an ether framework, but just explaining the mechanism of contraction differently. They completely abandoned ship so that they could always have the Earth's motion, because they knew that it could never be measured again. Like they all knew that there was an ether, and that if that Earth's motion was moving through it at those heliocentric velocities, it would be reflected in that fringe pattern, right? So because that's how the ether that's how the mechanism of the ether works, right? So they don't teach us or tell us that because the implication is so you can obviously deduce it like very easily, that the implication, if there's a fringe shift but one that doesn't correspond to 30 kilometers, that it's stationary with respect to an ether effect, right? And that's what they all got together, I think, and was like, so we're just going to talk about it in a way that doesn't imply this, right? Because
maybe
obviously
even the old we know it's a globe, so ...
Exactly.
Was there anything suspicious about Dayton Miller's death? Or was he just old?
I don't know. Probably
They hired
just
his
old.
assistant afterwards.
He just his heart gave out, dude. He got tired of disproven relativity and nobody caring. And he died of heart failure.
He must have been. You have to think that he must have been conflicted as well, right? Because he was still thinking that we're going around the sun, even though the results showed that we weren't.
Nah, man. He's just, like leave that for a different transformation. That's not his ballpark, right? Like he's just like, I'm just measuring this cool effect, and it's proportional to how we say the orbits work, but just not to the speed that we say. And but they couldn't.
You almost have to wonder if he knew, and he just couldn't say. And it was just like him playing dumb.
I don't think so, bro. He
was
an initiated man. He knew what he was like. He was part of the secret societies. I mean, I'm sorry, the royal societies.
He might have known. Okay. It's just that those are the kind of questions that come to mind. Like if his results are showing no relativity, and then he at the same time didn't realize how much the globe model's lifespan depended on relativity.
Oh no! These guys knew that, dog. Like they knew that,
right? I don't know. And that was just all speculation. I just wonder, like what actually happened with this whole like, because it's so damning. And the repetitive
publishing. Yeah. He just kept publishing, and they kept critiquing and naysaying, and then he would just do another experiment and address all the concerns, and they would just go, well, no, and just ignore it and all that. They literally couldn't go back to another to something where motion would be relative to that, because it would just reflect that their heliocentric model doesn't exist. So
throw a couple world wars in there with mass genocide and financial redistributions and controlling what they're funding and what they're not, and what people are being educated in and what they're not, and what's being suppressed and not available to their information channels.
Yep. So Germany actually made it like they stopped allowing criticism in academia. When I say they, I mean the people that are in charge of like peer review at the time over there. They stopped allowing criticisms of Einstein's work. And there's like this culmination of like 3,000 unpublished papers and like excerpts and just journal articles and whatnots of contradictions of Einstein's theories and all that stuff that have been suppressed. And they just uniformly decided that no one could criticize it. And then so when you're teaching people in academia, they're like coming up and you're teaching this philosophy, this interpretation to them, and they're seeing that like, oh yeah, okay, so moving forward, if you want to get a job and have money and all this stuff, you need to learn, these relativistic effects and these calculations and this, and how relativity works and stuff. And that's just what they did moving forward, to obfuscate the ether situation. And it was like literally just funding. And then if you criticized Einstein, they called it the Einstein treatment. And what that meant is they would call you an anti-Semite for criticizing him. There was 2 debates that Einstein backed out of, and it was, he was going to defend his theories of relativity and stuff, and he couldn't do it, and he backed out of the debates. And the reason he backed out, he said, was because the guy that was questioning him was an anti-Semite, and he's not going to dignify a response to to an anti-Semite and all that kind of stuff. So like they just use a shield to hide criticisms of the theory, and you get high praise if you're really smart, you're an Einstein and all that kind of stuff, right? So it's just kind of been culturally accepted that these theories and equations and the cultural acceptance of the story and narrative is that if you're smart, you're an Einstein. So of course everyone's gonna
Have you heard of
conform to that.
guy?
What's that?
Have you heard of this Whitaker guy?
Sounds familiar.
Essentially, Einstein plagiarized all his shit, and this Whitaker guy made
Whitaker
going,
something. Yeah,
all of it was plagiarized, like every equation, everything, the whole thing.
I mean that's about par for the course, man. He stole from a lot of people's work, and then over the variations where he had to change the mathematics to maintain covariance, they just kept stealing work, and then it got to the point where through absolute differential calculus, they could just use like a huge mathematical reification fallacy in the form of a tensor derived to explain the conservation laws. They could just use that as their mechanism to establish covariance. And once they had that liberty, I mean, it was game over. They could just say anything and bend and warp space-time to conform it to whatever they needed to and get the results. Mathematically, that is, like get the results mathematically. And you know what they say, if you can calculate it, it's definitely 100% true.
And as long as it matches that ball, the ball on the TV, you're good to go.
Yeah.
The math is also when talking with people about measuring things in flat Earth. I want to like measurement with something with that kind of tool, and I often get answers like that's mathematically proven, therefore it's science. But that's not always true, because you can mathematically do multiple things without measuring anything. And if you don't measure to confirm your equations with mathematics, then it's not kind of science. It's just a wild guess, I think.
Right.
So
well, it's what they do with. Yeah.
Yeah.
Well, I was just gonna say real quick.
Yeah,
just to interject real quick. Yeah, when they claim to shoot things at the moon, like radio waves or lasers, etc., like they're using the calculations for how they are just reifying how the electromagnetic propagation would happen in a vacuum over those distances. So it's just an example where like that's all calculated, but they're trying to claim it's physical.
Yep, exactly.
Yeah, exactly. They put the calculations like in a place of a scientific test or some kind of measurement, and that makes me like okay, come on, that's not real science. That's just a calculation how it might work. Have you tested it? No, but it's enough that we have the calculations. All right. So you kind of don't want to prove it like with the testing. So no, okay. But that's kind of one kind of smoke and mirrors or kind of thing that they just put the calculations instead of real measurements. For example, we talked about earlier Earth's spin. how it should be like measured, a different velocity, or what you want to call it, a tangent of the movement in the different places. Let's say in the equator it's 1,000 miles per hour, but in here where I live, it's only 800 kilometers per hour here. So it's half of that speed with it's in the equator. And is there any tool that you can use, put it the same tool in the equator and bring it back here in 60 North Finland and see the difference in that tool? No, there is, but you can calculate it. That's one, for example, what comes to speed of the Earth spinning itself, so around itself. So there is no any measurements that you can do that, okay, in this place. And of course they say like if you go into the North Pole, you don't feel there's no kind of speed at all. You are just sitting on a chair watching all direction at the same in a 24 hours, and speed is like 50 degrees per hour, but it's not you are not like kind of moving anywhere, just rotating around yourself. But that's kind of if I go into the Wonderland, if I go into the Disneyland. I don't want to go into Disneyland. I can't go to Disneyland. But yeah, they are just they are not measurements, they are calculations.
I don't think people realize that there can be like mathematical fallacies, just like normal logical ones, and that's like something they got to get across to them.
Can math lie though?
We also like
it should be measurable. That's the thing. It should be measurable. The interferometry. I mean, they use these interferometry gyroscopes on airplanes to get very accurate XYZ axes movements. That's why they use them in airplanes, to get the accuracy. And they are accurate enough to be. They should be picking up the motion of the Earth on its axis, and that it's tilted, and all of those measurements. And then it should also be able to measure that whole thing, which is moving on its axis, is also moving around the sun, and in all of those vectors as well, and the tilt. Being on a tilted globe, going around a sun in what they call the ecliptic plane, because it's a planar path that the Earth is making around the sun. They call it elliptical, but it is planar in that sense, meaning that's why I call it the ecliptic plane, the path of the Earth around the sun. So you should have the readings of the actual Earth going around the sun with the tilt of the globe, and all of those like cross vectors where the globe is tilted. So at every latitude, you would have that tilt vector in relation to the plane. That all should be measurable. If that was happening, that would all be measurable with the devices we already have. But instead, it shows the consistent sidereal movement that we see of the stars. That's what it actually shows.
I think the Earth is rotating though, because I just watched out of the window and my motorcycle is falling off. I was just, what's there in different, like, okay. I think yesterday I came home very in the middle of the night, and I think I put the motorbike to like a straight, and I think there was a wind or something, but now I see my motorcycle is like an, do you say fallen off, or how do you say it when it's like not standing straight? It's kind of when somebody like fall. How it's in English?
Fell tipping.
When you kind of hit your face on the ground, what do you say? What's that? What happened? Did you fall?
You tripped and fell?
Tripped, but what happened to my bike? Now my bike is like face down.
Anyway, I think like a face plant or something.
Maybe I take a photo of that so you understand. But I don't know the word of. I think it's fall, but it doesn't.
Yeah.
It fall. It fall to the ground, so it hit the ground.
Yeah, that's right. Yeah, fall. That's yeah.
Yeah.
Fault. Yeah.
All right. I will go and now raise it up because I don't think she's feeling well. So be right back.
Yep. I'm back.
Yo.
Yeah, so I missed most of what you were saying, Alan, tonight. I saw you put out a video a little earlier about is Michelson Morley an actual experiment? You did something like that when we did the ether. Was it kind of a recap or a rerun of the thing we did about the ether roundtable the other day? Similar?
Yep.
Cool. Yeah, I was mentioning it in here. I actually took a bunch of screenshots from your presentation and placed them in. And that's when Kosho came in with his, as much as I like Alan, he was wrong about, the GPS.
Nice.
He doesn't know first order measurements or something like that. We'll have to get that set up with Kosho to actually have that out.
Yeah, that's dope.
You remember what he said, Gio, about the first order measurements being like, he's like, those are first order measurements. The ones they're getting, those are first order. They don't need to make the corrections. No, it couldn't be. Can't be.
Yeah, he was like debating you even though you weren't here.
It's the only time he seems to want to do that.
He's definitely got it all thought out. Like he's got a whole presentation on it. He's been thinking. So, but I think, I don't know that he fully understands, a lot of what you shared though either. So yeah, it seems like there it could be further, but yeah,
I think he understands quite a bit of it.
Well, he likes that you guys agree on the precision of it.
Well, maybe I shouldn't have said it. Yeah, maybe
the precision of it actually works against the globe model. That's the problem. He doesn't realize that yet.
Well, I guess I rescind saying he doesn't understand because I don't like to say that about people anyways. I don't really make judgments on what they do or don't. I guess what I more meant is that you guys, you and Kosho went really deep into that one night. You guys did. There was a lot there. But what I heard him saying the other day, what I'm saying is that it sounds like there was some components that I could imagine you guys would talk out, basically. So, like there's some further integration of the ideas, basically, is kind of what I'm trying to express. That I think is in potential there.
Oh, gotcha. Yeah, definitely. Whenever he gets around to it. Sorry, were you talking, Dave? Or
no? I said, Kosho, if you're listening, get in here. Go ahead. Oh, I figure he keeps a open line sometimes.
Well, if you guys wanted to do that, I mean, if you guys wanted to do that, we could just do like I could DM Kosho maybe and see if he. Because you guys were you both like agreed to do that, right? Like maybe an hour or two event or something and go through it all.
Yeah, absolutely. Just let me know the time and day, and preferably anytime after 8 p.m. EST is good. It's like 9, 10 o'clock, stuff like that.
All right.
That was cool having
can conform to any day.
That was cool having a model builder in here a couple days ago or yesterday or whatever it was.
Yeah, having him come back. Those diamond GPS patterns over the water is so crazy, dog.
I was busy at the time and I was just kind of listening in. I didn't even get this. Did you save what he was printing or he was posting?
Yeah, so he was showing us the diamond pattern formations, which that only occur really over the oceans, where they would be hiding, stuff.
Uh-huh.
So that was a big part of it. And then he went over the true ground speed versus the relative airspeed that they give us and how they don't show that for the stuff in the south. He gave us the place that he got the data from. I think it was 24 something flights or something. I'll have to go back. But yeah, we have the name of the place, and when you look at the public data, it doesn't show the true airspeed. They hide it, but his GPS data shows that it's going 250, 350 miles per hour faster than what's needed. So just like the basics. And I think there was some great circle stuff that went into that as well, because you can see from the flight paths that they're not following great circles. Like they'll make these weird corrections or do whatever and just kind of beeline it to the next GPS checkpoint or whatever it is. And apparently you can't really do that on a glob that may or may not be rotating underneath you, depending on what reference frame you believe you live in. So there were some issues with that, and then they got into Coriolis towards the end of that. That's where I checked out.
Okay, I'll have to go back and see if I can find that. Actually, sounds like it's really
Yeah,
interesting. What does the diamond pattern indicate? Why would the diamond pattern make a difference?
So it looks like they're diverging and converging to like some sort of grid system. So like you know how like you know how they're like, oh, we're following a great circle route and all this stuff, right? Well, they're not. They're diverging and converging to like checkpoints in the ocean. So we think that like maybe there's like some sort of buoy system or some sort of grid system out there that they're using. And like so like when you know how the planes are basically just autopilot navigating and sorting out the routes and the airspeeds and all that so that they can get to their destinations on time, irrespective of the time in which they took off. So like what they would like a good indicator of that sort of thing would be not flying directly to the location and like taking these weird divergence and convergences in your route when you don't have to hit these checkpoints. But that would like provide the mechanism where it would delay or speed up the flight relative to what it has to match on the globe, and then arrive on time, you know, based on the fact that it took off, you know, 15, 20 minutes late, but everything still has to cohesively work. So like that's what they would this is like a grid system that they would use to facilitate that, and it looks exactly like that.
Wow.
Like that's what the grid,
that's
what the diamond pattern is, you know. Because
it's
only in the ocean areas, right? Too, so they don't do it like that over land where it would be obvious, right?
Right. Well, this is dangerous territory. Pun intended.
Yeah.
He's great. He's a great find for sure. I definitely think that he's going to be around for a little while. Hopefully, he's got something big too. He said he got a big ISS damage control find that he wants to present next.
Yeah, I'm excited for that, man. He's got a lot of interesting stuff to bring to the table.
Right, good sense of humor too. He gets it. He just gets it. Even if it's easier to understand him all the time. You know, takes a little while. Just have to be patient.
Yep.
It's cool that he's not too nervous to do it still. But just got to just try to get it, and then he's here. He's in it for like the true like value of it. You know, like he understands that, you know, this is bigger than anything that, you know. I don't know. It's the bigger picture he's looking at, you know, as far as like what's right and what's wrong.
Yeah.
He's on the same page.
Jeez, dude, you trying to build a statue to him or what, bro?
Yeah, I'm down with it. Model builder. I'm gonna build a model of model.
Build a model of model builder. Nice.
Why not? I'd like to meet him actually. That'd be a cool reason to go to France, man.
Yeah.
Yeah, I'm gonna have to check out your latest rundown on the Michelson Morley. Basically, from what I got from your presentation, is that, you know, the hypothesis is that, you know, it has to be either one or the other, right? If it's this, then here's the ether drift for you, and if it's not that, then here's without the ether drift, right?
Yeah, I think that was it.
Cool. Yeah, I was your biggest cheerleader, and I still am.
Nice, bro. Thanks.
I'm going to build a model of Alan as well as model builder.
Also, the ether is kind of weird that I earlier talked about the other speeds that we are going. Like, why those are not affecting the ether or the light? Because the light is not a particle. So it shouldn't be affected by any movement. So about let's say the medium, if the medium stays same but the medium is moving itself, very difficult to improvise. To put a figure in. But let's say the Earth is on some kind of one medium, and the light is moving there in one speed because the medium doesn't change. but the whole Earth, including that medium, is traveling somewhere. So then, therefore, the light should go faster when it's beamed backwards, so to speak, and go slower when it's going forward. But according to the Einstein theory of the shortened theory of relativity, the speed of the light doesn't change even if the object or the who is inspecting the speed of the light changes, which of course is a lie to make things like look better. But of course, if you beam the light, and let's say you are traveling with the half speed of the light one direction, and you beam it towards, the light speed is different if you put the light backwards. But according to the Einstein, it's the same. And yeah, there are lots of things in Einstein theories that, like the bending of the space-time and the speed of the light and stuff like that, which are not true.
Yeah. Yeah, there's a lot of that going around in his theories. You know, I agree.
Also, the thing is, we don't know what the light is. There's no clue what the light is. It's a miracle. It's a kind of there is no scientific proof of what light is. A particle, is it a wavelength? Yeah, because it has some characteristics of both. It can change the direction or bend. One funny thing is when you put from a less dense medium into the denser, let's say you put it from the air to the water, it will slow down. But when it comes back from the other side of the glass of water, it will speed back up. It's amazing without any. So it's kind of, we don't know what it is.
Yeah, I think they actually say, to get around that, they actually say that when it's going through the other medium, it's still going the same speed, but it just has to take a different path through the medium, like through its like molecular structure, and its density, is relates to how much, it has to go through this maze to get through. And that's why it's, comes out on the other side still going the same speed, because it always was. It just refracts because it's taking a maze path to get through the medium. It's crazy, huh?
Yeah.
Instead of just admitting that it slows down the propagation. They're like, no, but it slows it down in a way that it just looks like it. It's like, okay, dude, cool beans.
But I think that they disproved very early. Was it the Aries failure? They put water inside the telescope to prove the movement of the Earth, and that failed that test.
Yep. So there was Aries failure and Fazoo or something like that. It's some French guy. He did a thing with same thing, and completely body bag heliocentrism, or the idea that the Earth's in motion. And they were like, "Oops, I guess this ether theory must be wrong."
Yeah, but it's amazing that because they were looking like stars or whatever through the telescope or something like that, and that putting the water, changing the medium should prove the movement of the Earth. And then they figure out, okay, the Earth is not moving, the stars are, because of that test. And yet still today, that test is, I think it's valid to prove the Earth is not moving, the stars are.
Yeah, that's how we live in the upside down, bro. Like it's just, they just completely invert it. And so what, like Witsit was saying, what they do is they take the evidence that directly refutes their model the strongest, and they just say that actually is what proves their model the best. It's crazy, but it's how they get away with it. They just in your face tell you that Aries failure was a failure of the ether or whatever it was, and then they're just like, but it was a positive for Earth motion. It's like, what?
Yeah, it's amazing how. And yet again, when like we talk about this and argue with other people, and we came conclusions, there are people listening these conversations, and they only look the real science links, like they go to the space.com or whatever, and there is the answer fact check, so to speak, and they rely on that. So okay, that was failure according to fact checkers, so therefore I don't have to think myself at all, and I can what is the word, I don't have to take this test into my kind of I don't have to like believe this test proved anything about the movement of the stars.
Yep.
So, fake Professor Dave, did you already tell your story? I guess I haven't been on the panel with you yet, but I know you're probably giving your flat Earth awakening story already, huh? How long have you been in the conversation?
I've been in a flat Earth like 6 years, and I've been here in Discord. Not this channel. I first went into the 24/7, but I think I've been here a couple of years. But I have times I have to go away from this to just live the life and forget to time the whole flat Earth thing for amount of time I want to get, like,
that's
because
healthy.
it's so frustrating to try to tell people who don't want to hear anything, like,
right.
So, but
Yeah, we all know.
6 years from what about
Have you
the guy?
did you lose a lot of friends and family to the conversation, or just stop talking to a lot of those people?
Funny thing is, because I'm a Christian and I have Christian friends, and one very good, my Christian friend is mocking me about this flat Earth thing, and he understands there are some conspiracies going around, but yet still the flat Earth is the thing that he's mocking me about publicly. For example, in my Facebook page and stuff like that, and Christians should not do that to each other. It's kind of, we are brothers and sisters. We should support each other, not go against. And it was a weird thing to happen in a person's, like, in real life we are still friends, but I had to put away our friendship in a Facebook. I said him that okay, I cannot let you talk in anymore in my Facebook page, but I'm still your friend in real life. But yeah, not many, but a couple of those happened.
You sound a lot like Drace. You know Drace from 24/7, Drace Love and Wisdom?
Not familiar with the name, but I might recognize.
Are you from Iceland or that area?
Kind of. It's very icy here in Finland, northern countries in Finland.
Yeah, okay. Yeah, you have a similar accent that he has. For some reason, I thought I might have heard you guys talk to each other or something. Maybe not.
Might be. I don't. I'm very bad at names.
Yeah, he does songs and stuff like that. You'd probably know him. You might like talking to him if you don't. You guys know Drace. Yeah, he's good. He had a friend that was also of similar. That's what made me think of it as well as your the way you sound. He had a friend that was was studying astrophysics, and he and his friend, are still friends, but it was kind of like a decision not to talk about this subject any longer. Like, this subject's off the table, and I think it was the whole idea that we're seeing different stars at different times of the year, and he was asking his friend, who was an astrophysics student at the time, how is it that we could see these stars, that are on the other side of the, where we should see them, and where, half the year. And And one of the things I guess that one of their excuses or one of their reasonings is that there's some kind of gravitational refraction going on with the sun, where the stars are taken from one side and then put into the sky where we wouldn't really see them, but now we're seeing them there because of this gravitational refraction from the sun, pulling the star and then putting them up with the other stars as if they're there, but they're not really there. And he said that was it for him. And he said his friend quit his astrophysics career, or his studies. And he like quit that as his major. And, he still won't talk to Drace about it. They're still friends, but he won't talk about this any longer, even though he decided not to go into this field after realizing how ridiculous, he had to literally bend over backwards to bend the stars up into the sky the way they were appearing. Anyone, you ever heard that theory before? Anybody else?
I've heard that story.
I haven't not, and I'm very interested. Do you have any more info about that? Because I have a couple of astronom hobbying friends, so I would talk with that. I would investigate that myself. But if you have any information about that, so you said that the apparent position of some star is different than the real position. What you meant?
Gravitational refraction from the sun. I'll have to DM Drace to get because at one point I had screenshots of it. I could try to look for it, but it was ridiculous. They even show a graph of it, like the sun's gravity is pulling the star into this place, around where where it's not really. It just looks like either a star, but the gravity of the sun is making it refract into the sky the way that it has to be.
Follow up on that.
Okay.
Yeah.
Okay. I would be interested to see some kind of more info about that. So if you have,
I pushed him for it, and he said it was just so ridiculous. I'll have to get the details again, because it was more like his friend had found that out, and that was like the only thing he could find to like explain it. But it doesn't seem to be too much documentation showing exactly, too much backing to it. Maybe it's just too ridiculous for them to even try. I don't know.
Someone came in ADL one time a couple months ago and told a similar story about that, and they linked a couple of PDFs and stuff that they made themselves, actually. But I can't find them. And it was like in reference to exactly what you're talking about, and it had all the stars and all the diagrams and everything. But I can't find it. I would love to have that again, because it was the same story. It was like this dude was like, "Yeah, I'm about to be an astronomer. This is dope. I'm going to astronomy school." And then he was like, "Hold on a sec, bro. What do you mean we could still see these stars, whatever it was, 6 months later when we're on the other side of the sun?" And the explanation that they gave, made him, he was like, "Okay, well, this is, I'm out." And he had a whole thing for it.
There you go.
I can't find the links to it. I would love to.
Interesting. Yeah, it seems like it must be something really detailed that, like, there's a point where it really can't be explained. So they had to like dig deep for this explanation with certain circumstances, with certain stars, and it's just not like a really popular theory because it's just so ridiculous or something. Yeah, that is interesting that it's not something that more flat earthers haven't pounced on. If this is what they're trying to say happens, I'll see if I can.
So basically, now I think I get it. So basically, if I now see some stars, let's say to the west or sideways, not to the north, because the sun is not in the north. So I see something at the night to the, let's say, west, and half year from here to the west, I look, there is a sun, and I see the same. I should see the same. Actually, I see the same stars, but the sun is actually there. Oh, sorry, I mixed up. So, but the sun is like blocking those. Yeah. The sun is blocking because the sun is in a that direction that I looked half year ago. I only should see the sun, but I actually really see the stars, which I saw a half year ago. Yeah, now I get it. So it's kind of the sun is in a way, so to speak.
Right.
It should be.
Exactly. Should be.
Yeah, it should be actually. Yeah, it should be in a way, but it's not in real life. Yeah.
Right.
Yeah. I heard that. Okay, that's so ridiculous. You could make a stand-up comedy about that. Only
Oh
talking
yeah,
about like 15 minutes about that with a full crowd of with a brick wall
right.
behind yourself. That's how ridiculous that is. So,
Yep, yep. We were laughing about it. That's why I remember
yeah, I
that story.
understand. Okay,
Like,
yeah, that's a different because I live so north. I don't see much stars in west or east direction, so to speak. I see mostly the northern or the center hemisphere, what you want to call that. So I see the North Star and whatever. I'm 60 north. So if I would be 45 in a equator or somewhere there, then I should look west or east, so to speak, to watch those stars. Yeah.
right. You know, hey, Gio, are you still here?
Yep. Yeah, I'm still here.
Have you heard that before? Have you ever heard of this gravitational refraction with the sun?
I was listening mostly, but I was also multitasking. I did hear that, but I don't know that I picked up all the parts of it there.
You
When
know,
you were
Drace, Love and Wisdom, right? From 24/7, Drace.
Yeah, I think I know. Yeah, I
I'm
know
looking
who
for his account. I can't find his account. I wonder if he's been deleted. Oh, here he is. Drace AI. He's going by now. Okay, I'll message him.
Are you talking about the
Yeah,
Eddington experiment?
I don't think so. What's the Eddington experiment again?
Where gravity makes light bend?
Ah, okay, that would be similar to that. Then,
different.
yeah.
This is a different.
Different gravity
This is-
making light bend.
You know the
Yeah.
argument where people or flat earthers say, well, how is it that we see the same stars 6 months later when we're on the other side of the sun? Right? Because the sun should be blocking where those stars are. I mean, you have to look around the ball to see where those stars are, but you can still see them in the night sky 6 months later, right? Well, there's supposedly their excuse for that, or one of the things they pull out for that, besides the sidereal day and all that, would be that there's gravitational refraction from the sun, and the sun is actually pulling the image of the star to look like it's in the sky, but it's not really in the sky. But it's like pulling it around from the sun, right? And Alan says he's heard the same thing, but he can't find any information on it. And I can't. Let's see what Google says. If there's anything about that.
Well, we do see
about
different stars 6 months later. Like we see the other side of the star field in a sense. I don't mean other side in terms of the way they claim it is with a huge 360-degree sphere, but even like just viewing them as like the face of a clock, like we see the other half 6 months later. Because the sun is illuminating the blue sky in the opposite section 6 months later. But are you talking about the nuance between the sidereal day and the solar day and how that matches up with the calendar, or are you referring to just the star field itself? Or
well, the question, the story is that he had an astrophysics friend that was studying astrophysics at the time, and he asked him about how it is that we see these stars 6 months later, even though
It's
they
a
should
certain
be
set of stars.
Yeah.
We just don't know the name. To go along with the story. But yeah, the question is like, how do we see these stars on this side of the sun when they should be on the other side if the Earth is on the opposite side 6 months later, right? And the answer that they gave was something about gravitational refraction, just for these stars specifically, so the guy quit being an astronomer or whatever as the story goes.
Yeah, he quit. He didn't want to ever talk about it again, but he quit studying astrophysics after that. And that's when Drace realized this is it. That's the final straw for him, at least. Yeah,
they have added the Chat GPT in the Quora as well. So there's very interesting answer from Chat GPT. I will put a print screen of that if I can just a second. That's That's amazing.
Here's
That
how the sun
it's
warps starlight. So this would be like gravitational lensing, which we've all heard about, I guess.
Yeah, this is all
But yeah.
based on the Arthur Eddington mythology experiment. Right.
Yeah. Okay.
Like
Here's something
the
that looks like it
concept
has a
of
video too.
gravitational field altering light.
Yeah, the Eddington thing's the only thing I've ever heard of that makes light bend or gravity making light bend.
this is the ChatGPT is answering. Where,
Go ahead.
oh, sorry.
No, I was just
The
gonna say there's a video in the
ChatGPT.
link I just put. You can watch the video, and
Okay.
it kind of shows a little bit of what the idea is.
Okay.
Go ahead.
Okay, but yeah, I was wondering because the ChatGPT seems to be very clever, but in here, Mr. or Mrs. ChatGPT is talking some nonsense that's not even English. What it's kind of the stars are so far away from us that their positions appear to be fixed in the sky. This is why we see the same stars throughout the year, and even the Earth is facing different directions on or in its orbit. So because they are so far away, therefore we see the same star throughout the year. So the reason doesn't come in that sentence. The ChatGPT, it's a clever thing and it looks very clever, but there is something wrong in there. Well, I will look now the NASA video about the illustration. Thank you.
Isn't that their actual explanation though? The reason that it doesn't change, and it's that they're the same, but they're so far away that by the time the light catches up to us and we're rotating in a new spot, it just like uniformly looks the same.
Yeah, actually, that's why I heard that when there is this sun eclipse, they investigate this sun gravitational pull, and it can move the stars like maybe 1 pixel in some camera or some millimeters. But you can Google it. Yes, there is something happening when the stars, which are then back behind the sun, might be a little different, but not much, not so much that we could see them. But yeah, and I think they are like hanging in that, like, okay, because we see a very tiny difference of the stars position when there is a sun eclipse, because then we can actually see them because the sun is blocked by the moon, so to speak, if you believe that. But yeah, there is a little, I agree that stars are a little different when they're very close to the sun. If you can trust them, I don't know if you can, but yeah, I've heard that as well, but that's not much. That's just a tiny bit. Yeah. And they can hang on to that kind of fact that, okay, during the solar eclipse, we can see the stars are little different places around the sun. They are moved. So they can say that, okay, therefore we can see the night's stars in the night, which should be behind the sun. I don't know. That could be like a very bad explanation or kind of proof for that side. So keep that in mind as well.
Like we need anything more than Michelson Morley. It just keeps piling up, I mean, how many things need to pile up before doofus finally stops being doofus? Such a doofus, I should say. It's funny to watch him and Gleam. Is anybody reading there back and forth?
No.
Gleam. Do you know who Gleam is, Alan?
Never met him.
Gleam is great. Gleam, get in here if you're listening. He's in the text chat. He's got a lot of great information.
Nice.
He knows his shit. He's
Just
always
mop on the floor
like
with Rufus.
Yeah.
Nice.
Yeah, he's always back and forth with little arguments and with these guys, he doesn't like to call himself a flat earther because he doesn't want to label or whatever. But he's always just like out for the truth. It seems like that kind of guy.
That's what's up.
He hates the fallaciousness of the globe model.
Yep, that's what got me too, man. Seeing that every argument had to start off with, well, because we know it's like a globe. And I was like, nah, that's not how you're supposed to do it, bud. It was like literally every proof was just like, well, actually, because of the curvature we know has to be there to fit the model that we're trying to prove exists. I was like, all right, you got me.
Yeah. It's like you cannot. Okay, here's the argument, but the only way that we're going to have the argument is the room we're in is glob, right?
Yeah.
And you can't go outside this room. So as long as we're in the glob room, we can talk. We can argue about all the details. We can argue between one thing and another as long as it includes the glob, right?
You know what? I bet you. What do you think they would say if like instead of saying like, yeah, we're flat earthers or whatever? What if we were like, no, we're globe earthers. We just think the globe's much bigger. Like we just and that the solar system is much closer. Do you think we just kind of changed the scale invariance of how they derive the sky relationship to the ground?
They can't have it be anything different. As we know, they can't change their numbers at all. They change one little thing, the whole thing falls.
That would be funny to make like a bigger globe move. You know?
Yeah.
We're like, we're the bigger globers, guys. Come on, let's go.
Dude, we actually say it goes way faster than 30 or 60 kilometers, or what is it, 30 kilometers a second. Yeah.
Right.
Like we should have our own ridiculous globe model that's just two scales, the 2x's the scale factor of theirs. And we're like,
make it like a glob comparing contest, right? Our glob's bigger than yours. We're way better than you.
Super glob.
We'll make up something called Gleether.
Alexander Gleether made a azimuthal projection map of our glob. That's way bigger. Yeah. Yeah, I'm down. That's awesome. We should totally.
We might as well.
Everything's bigger. Like the gravitational equations are bigger. Just everything's bigger and better.
We use a bigger G instead of using
even bigger G. Yeah, it's little G, big G, and even bigger G.
Right? Yeah. That's great.
The biggest G.
Bigger G. Our G is the biggest. We got the biggest G around.
The G of all G's. Yeah, we should definitely do some sort of meme like that and present it like, no, guys, we're not flat earthers anymore. Like, that's crazy talk. Here's what we actually are now. We're insanely huge globers. Like, the size of the globe is just ridiculous.
The way you said that, because you're talking about a big globe, but calling yourself just a big glober, a massive glober. That's so funny. We are really big globers, guys.
We're the biggest globers. Like,
we would just outglobe everyone. Yeah.
Yeah.
They're hiding the new fans.
Like, oh, you're looking for a geometric horizon on our globe? Good luck, bro. It's so big, it's flat. Allegedly.
It's so big as it appears flat,
right?
Even the longest range we can see. So,
yeah, the only way you can extrapolate curvature is through lateral image compression. And that's the only proof that we'll accept that we live on a giant globe, a super globe, if you will.
It's the only thing to explain
the biggest, flattest globe you've ever seen.
Yeah, the globe's not oblate. That's retarded. It's just 4 times bigger than what they say it is.
The most flat, biggest globers ever.
Right. Well, we might as well go that direction or something because it's just so ridiculous. Might as well just meet their ridiculousness, like you're saying. That makes sense.
Well, it is kind of interesting, actually, in the way that, like, because even that term "flat Earth" has so much, like, history to it, just like messy psyop history. The way that they've with the Flat Earth Society and then pushing the globe so hard and getting it over on everyone, the globe, to the point to where, like, the term "flat Earth," and all the programming around it, to the point to where when people hear that term. Or even if you don't use the term and you just start, talking about the Earth, they might even say, because even if you don't use the term flat Earth and you just start describing, certain things,
Just start describing geometry, they freak out.
Right. They're like, you mean flat Earth? The red light goes on. So like I'm saying, if you actually did a movement, like a bigger globe movement, and then came with all the reasons why it has to be a bigger globe, that would actually be funny, because like would society accept it more? It's like, oh wait, okay, so you're saying it's a globe, but it's way bigger than they're telling us. That would be funny to see, like whether people are like, they're not like flat Earth triggered, and they might. I just wonder what like the social implications of that would be.
Oh, it would be way more. That's the funny part about it. It definitely would be more acceptable, as long as it's a glob. Because there's even globers that say, "Oh, well, what if it's just a bigger glob? That's no big deal." We've heard them say it. Like they don't realize that the numbers have to be exact for it to work. But that's the whole point of this, right?
I have heard them at times over the years, especially like if they're in like an intellectually honest mode, whoever it is, if they're in like a chill mode and they don't feel attacked or anything, and breaking down these certain things, they often will be like, okay, well then it would just have to be a bigger globe. And then the next thing is like, well, okay, now you got a bunch of problems. Everything's off at that point. The whole thing, because that's the funny thing about it. We're joking about it now, but I mean, you can't make it bigger and make it work. That's what's funny. But you have to make it bigger to fit the observations. So it's funny.
Yeah, I'm a big globe, small universe model kind of guy myself.
Big fish, small pond kind of guy.
Yep.
Nice. I'm a big fish, small outer pond kind of guy.
And the Earth in my model, by the way, isn't in the center. It's slightly off-centered because it's insignificant as fuck.
Nice. Okay.
So it's a big insignificant globe.
Yeah. It's huge and insignificant.
Right, but way bigger than the sun. Right, we're bigger than the sun now with this model.
No. So the way we're going to scale it with scale invariance, the bigger we make the Earth, the bigger we have to make the sun and the moon proportionally for everything else to scale.
Mm-hmm.
So yeah, the sun's about to get way bigger too, but also way closer.
Or do we want to go smaller? Make the sun and moon tiny little things above the big glob.
Dude, are we about to become tiny globers? Dude, the reason we can see so far is because the globe's way tinier. Yeah, we could take it in either direction, bro. We could actually set up a debate: big globe versus tiny globe. And we could sort out the discrepancies, and no one would be able to differentiate between the two models.
Small local sun and moon on a massive
local massive globe.
Yeah. And
I have often
an azimuthal grid of vision added in there too.
Yeah, I mean that's standard for a model, right?
There's so many different names for that. There's so many different names for that phenomenon. It's pretty wild. Yeah, like I don't know if there's ever one that will stick, but yeah, that's the one that Witsit did. I don't know. Did Witsit come up with that wording of it, or he was the first one I think I heard saying it that way?
I think Shane came up with the wording of it because originally Jaron was calling it the personal dome of vision or something like that, personal dome of visibility, and then Shane called it the azimuthal grid or azimuthal perspective or something like that, and then whatever Witsit said, whatever variation that one was, like slightly different from what Shane said, is the one that everyone goes with now. But yeah, either one of them, it all describes the same thing.
Yeah, I mean, even just like field of view, in a sense, just like the field that is your ability to view.
Yeah. How cool is it that we see in a toroid, man?
Yeah. That is epically interesting to consider that we are toroidal perspective machines. Just walking around.
Just a coincidence.
Just walking around blasting a huge toroid and just just manifesting an Earth in front of us within our toroid.
Just interpreting the nature of reality through our toroidal vision, you know, whatever.
Just taking it in through our aura, emitting, propagating through the ether, toroidal propagation through ether of larger toroid.
Yep. Just toroidaling out, man.
Toroids all the way down.
Dude, I was just thinking that the other day, man, because someone was talking about the turtles all the way down thing. 'Cause I never heard that before. And I was like, ha, toroids all the way down, though. You know what I'm saying? Yeah, that's exactly it. Toroids all the way down. It seems like everything that's in motion, when you like break it down mechanically, it's like a smaller little toroidal vortex is like what's perpetuating that motion. And then we generate a toroid with our heartbeat or whatever, and we see in a toroid, like, you know, the Earth surrounded in a magnetic toroid.
Yeah, I often think about it too, like toroids all the way out, or toroids all the way in, or you could use them both, like toroids all the way from in to out, and because yeah, it seems like it's like layers of an onion, like fields of consciousness within fields of consciousness that are all subset within perhaps a greater and greater field, and then that getting to what the extents of that or the transcendent levels of that even are. But yeah, it does seem like that seems to be some foundational, at least in this realm. I mean, you know, if one were to speculate of other dimensions or other realms, things like that, could things be different? But this realm, it seems to be, it's like we're in one, and then there's like multiple layers within the larger one.
And then we're also one.
Yeah, fractally.
Yep. It's very Mandelbrot set.
Yeah, totally. That thing's awesome. Exactly. It's like a fractal subset within another, within another, within another. And each one, like the part and the whole, are one and the same, and they're within each other.
Yep. And it just goes on forever.
I mean, it's interesting to think about actually seeing in a toroid that actually is propagating through the medium, because it made me think of, have you ever had that experience where, like I've had it throughout my life, well, I'll be sitting, is the best way I can describe it. Like I'll be sitting in a car in a parking lot somewhere, maybe just some big parking lot where, you know, some store or whatever it may be. And I'm kind of just maybe doing something, or I'm on my phone for a minute, or I'm looking something up, or I'm just chilling for a minute before, either when I first get there or when I'm about to get on the road, like whatever it may be. And I'm just chilling there, and I see someone walking by, and I just, like, I'm in my car, you know, and their back is to me. They don't even have me in their periphery. And I might just be looking at them. I'm not even talking about like people watching or anything like that. I'm just talking about in general, just like I just glance up and kind of, oh, I see a person. I just glance at them for maybe 2 to 3 seconds. And then they will like turn around and like look at me. You know, like I haven't had that many times in my life, but have you ever had that where like you're looking at someone from behind and you're not even like putting any intention into it. You're just kind of glancing their way, and then they literally like turn and like it's like they know someone's looking at them.
Yeah, I've been the turnarounder, dude.
Right. That's yeah, me too. Exactly. Right. Where you're like, what? Like,
I'm like, are you watching me, dog? Like, what's wrong with you? Eyeballing me? Yeah.
But like, if someone's walking away in that sense where they can't even, you know, are they like, yeah, it's just like, is there like a physical connection to actually seeing? Like physical that they're, or I mean, that could also be described through like a sort of psychic or, you know, ether on that level as well, like through maybe like a non-material.
Yeah.
But
the pressure mediation between your two toroidal fields, dog. There was a disturbance in the force, as they say in space fantasy. Right? So like maybe that person's energy, like when they were approaching you, you were set at one frequency and they're like, you know, on some weird shit and their frequency's off. and the interaction between your two fields, you were like, "What the hell?" Turned around to see what was going on, but you don't know why you turned around because, like, we're not trained to be in tune with that sort of aspect of our bodies. But, like, yeah, I could totally. I mean, that's if such a mechanism existed, that would be it, right?
Well, do you think this could be double blind studied? I wonder if this has ever been done where you could like blindfold people and then have other people like look at them or not look at them and then record the person that's blindfolded whether they're being looked at or not. And if that could be validated to be shown that there is a statistical significance of people being able to actually be accurate to that, would that then be potential evidence for some sort of an interconnecting medium, an ether of some sort that has to be interconnecting them beyond just what their eyesight would be able to do in a kind of atomistic, materialistic type world?
Yeah, it would be really hard for them to explain it because, getting into an interconnected medium or some sort of uh, Akashic record, hive mind situation or something like that isn't really something that would be like accepted in today's modern science or whatever.
Yeah, exactly. Because they just would say that we're receiving light from our eyes and that's it. We're just receivers.
Yeah.
So how could you look at someone who's blindfolded and have them actually be able to register it in an accurate way through just that means? That is
They've
interesting.
probably done studies on that kind of stuff, though. Have you ever looked into the stuff that the military did, where they had people doing like remote viewing and staring at goats and trying to get them to die and stuff, like stop their hearts just by looking at them and like using their thoughts and stuff like that?
Yeah.
They've totally invested a lot of time and research into that kind of stuff. I'm sure a lot of it panned out, and they know how to utilize that stuff for sure.
Yeah, no doubt. I know they're all into that. And Rupert Sheldrake also did work in this field where he did the ones, for example, where like owners and their dogs. So they had like a camera set up at the home to like monitor the dog's activity. And the owner of the dog would be, let's say, at work. So they're like, let's say 30 miles away. They're in an office building, 20 miles away, whatever it may be. They're at work. And then they have a camera on the dog at home. The dog's just at the house lying on the couch or whatever. And what he showed, which he called it the morphogenetic fields, morphic fields, these kind of fields that I don't know that he goes full ether with it, but he does talk about these interconnecting fields that biological organisms have. So the one with the dogs is to where when the person's at work, and then let's say they get off work, even if it's like they're getting off work early or they're getting off work late. So it's not just that the dog knows the time. And they've even done it where he'll get off work in the middle of the day or even like leave work an hour into being there kind of thing, like some abnormal timing. And he was showing how when the owner of the dog, like starts coming home, like they're like, all right, I'm leaving the office or whatever. And they start heading home. The dog will like, even though the guy's still 30 miles away, the dog will like jump up and go up to the door and start wagging its tail. And like, it'll show like a different behavior, like that the owner's coming home. And then if the owner like stops at like a store on the way home and actually just pauses coming home, the dog will like go back and lie down and kind of rest again. And then when he leaves the house again, the dog will get up and have that same reaction.
Dang, that's crazy. I think I've heard of that, but I haven't really followed through with it or like looking into it. That's crazy though. That makes sense. I've seen my mom's dog do some really weird behavior, like where they're in sync, and the dog will will change its behavior according to factors that it doesn't know about my mom, and it'll be in sync with it.
Yeah. Yeah, I have another quick story. These people had twin dogs, and their dogs were really close. And the one dog was at the vet or whatever, and it was miles and miles away. And the dog died at the vet. And then the other dog, the twin dog, like was at the house. And the same time that the dog died in the vet, whatever it was, the exact time was at the exact moment their dog at home just started howling and barking and like mourning, like in a mourning way, like
wow.
like had known that the other dog had died, even though that there's no physical connection that dog would have
Dude,
been able to detect.
Crazy, bro. I got a twin story for you, bro. Speaking of twin dogs and all that, I got a human twin story. So my buddy Tommy passed away 2 years ago. He has a sister, and they were identical twins and all that, and they, had that relationship where sometimes they would, sense each other's pain or whatnot and that kind of stuff. And when he passed away on that night, his sister had like this crazy dream where she had like all this anxiety and pressure on her chest and she couldn't breathe and stuff. And she, woke up and she felt that like there was something wrong with Tom and whatnot. And she was like all upset. And yeah, and that turned out to be the next day she found out that he passed away that night in his sleep around the exact same time that she woke up and like went through all that stuff. Absolutely
Wow.
crazy, dude. Yeah.
Wow. Yeah. Did she think that's what it was at the time though, or what?
She said she knew that Tom was in trouble, and then she said that like she knew that Tom was gone.
Wow.
By the way, did they claim that one of these astronauts has an identical twin? And it has disproven that those photos, them standing together, are fake because of some shadows on a t-shirt or shirt are exactly same. So basically, they manipulated the images. Like, do you remember that?
Nah.
So they are kind of, they sent one of the twins, identical twins, to the ISS to kind of make some science research how they kind of develop differently when one is in space and one is on the ground on Earth. Do you remember that guy? No? Okay. Maybe I'm remembering correctly. I will Google it shortly and I put it in a chat if I find something about that.
So they'll occasionally talk about when they send a twin up or whatever, they'll say like, "Oh, now this twin is what would it be? Slightly younger than their twin that stayed on the ground because of the difference in gravitational potential, which would change time dilation. So when they're in altitude, orbiting or whatever, they're experiencing less gravitational influence, so their time is changing faster for them or slower. I don't know. Anyway, that's they do say that from time to time, but there's no quantifiable, measurable effect from that. It's just a calculative number that has no significance, and they would never be able to be like, "Oh yeah, this dude's 3 milliseconds older now." Like, I would never mean anything.
I found the NASA article, but I have to find the where they are standing together in the same image, so to speak, or same photo. Where
Oh yeah, Scott Kelly and those guys. Yeah, those two.
yeah,
Yeah.
they found out that in the photo where they are standing in a real, so to speak, together, the jackets or whatever were exactly same. The
Oh, it's
shadows
just
of the
inverted.
jackets, so that they had exactly same shadows on the jacket, so they kind of missed that out. So, but yeah,
Huh.
there are not
Yeah.
much photos of those guys together, and they seem to be fake. All but yeah, I'm not sure about that, but they might be twins. I don't know, but there's something weird happening there.
Nice.
I was going to mention too, just with the one other thing I was going to say about the Rupert Sheldrake, the one other that he worked with, which was like monkeys, where these monkeys would be on one continent, and then there would be other monkeys on another continent, but they're like the similar species. And when the one monkey's on one continent, like learn a new skill, like they learn how to like use a stick and like to get ants out of a hole to like eat the ants, and they get a stick and they like when the one monkey's on the one continent like figure out how to do that, use that tool, it seems like the monkeys on the other continent like instantly have that skill as well, even though they didn't take any monkeys from one continent to the other to where they showed them how to do it. It's like they just have it in them automatically once the monkeys of the same species on the other region learn that new skill. So that's pretty profound too, like the potentials of that, because it makes me think about like even these conversations we're having here and in all of these different interactions. Like we were talking about this last night, Wits and I and others, like the idea of like, it's like we're like stamping the ether as we express ourselves in it and like creating waves. You could even see it that way, or like pulsations, or and like, yeah, you brought up the Akashic records, that kind of concept too. Like you're like adding to the Akashic library, as it were. And then in terms of ether and those effects as well, like what potentials do we have with that? Like in terms of when it comes to like the truth and other topics as well. So many different things that are related to this. If we're having certain conversations, even within a few of us, is the actual information, as it were, spreading like energetically, in a way that we're not even aware of. Like in the same way that the monkeys in the one area, like they just know how to use that tool. In the same way, like if there's some kind of invention or some kind of new idea or new understanding, or a series of those things that are in, as time is unfolding, is that actually in a sense like affecting others, even in a way that it doesn't mean that they have to like read it on their social media or even hear it on a live stream, but that it's like, but that there's actual, that those interplays are always at work. And like, and then what are the potentials of that as well, and like the significance of how either information can spread or truth can spread, or various like clusters of knowledge and information that could actually make even a more expansive effect, like the butterfly effect, even beyond what people are even taking in through their kind of ordinary senses.
Yeah, it opens up a lot of possibilities. Because like I said, like we're just not trained to be in tune with that sort of stuff, and kind of to be dismissive of it and not have any understanding of where we came from, where we're going. So it doesn't surprise me that the monkeys inherently, gain the new knowledge or whatever. They're able to access it in that way.
Yeah, makes me think too that if you hear that phenomenon where they're like it seems to be like multiple people seem to come to like a similar invention, even though they didn't like physically share the information with each other.
Yeah, I've heard of that sort of thing.
Like synchronistic
I
invention.
think this happens from time to time in a real life as well. Like I called my wife like yesterday or day before, and she was like, "I was just about to call you." It's kind of. Do you ever have this when you call somebody that just saying, "I was just about to call you," and just picking up the phone to call you? You have
Yeah,
had that with your friends or family members?
all the time.
No. Yeah, because there is some. I never thought about that in this way, but now you talk about these things happening in somewhere we cannot explain. I think there's something that we can like interact or have connection with other people in a level that we don't understand. Or we cannot perhaps even control it. It's just happening regardless our control. I don't know. It just comes to my mind, but it happened so multiple times that I was about to call you. I had the phone. I just picked up the phone to call you, and it started to ring, and you were calling me. And like with the people who like I maybe don't call once a week or something like that. Yeah, at least for me that happens from time to time. Not very often, but time to time.
Yeah, absolutely. But I think I'm gonna head off for the night, lads. It was awesome hanging out and talking.
Yeah, take care. Nice
Yeah, for sure,
talking.
Alan. Yeah, cheers, bro. Yeah, that was an awesome presentation, man. Thanks so much for sharing everything. And yeah, man, I hope you have a good night. And yeah, it was great to continue on for a bit these last few hours, man. Appreciate it so much. And yeah, have a good night.
Yeah, you too, bro. Peace.
Yep. Peace. Cheers.
one thing I usually wonder, and I don't have any answer. I don't think anyone has, but what your thoughts about when people say that, when you talk about what about the earth is flat, so the answer is, so what? I don't care. I have to go to the work. I have to drink my beer. I have to watch my Netflix. I have to go to the gym. I have to. Who cares? What's the? It doesn't affect my life if the earth is flat or round. What to say to that kind of people who, like, for me, it changed my life totally. My life will never be the same, like, ever. So
I would agree. Yep. I would agree. It's definitely totally life changing, and has incredible. I think when people say that, maybe they just aren't even aware of the significance yet, so they're kind of just early in the process of it to where they don't even know what the significance is yet, let alone actually, understanding it and connecting with it fully, because it's totally the opposite in my viewpoint. I think the significance is there's just voluminous reasons. It's there's a lot. Yeah.
For example, even I'm still in the world, but I'm totally free of change. I don't have any kind of every bird. The kind of I'm free of this prison. I'm mentally free. I'm physically here. I'm still obeying the laws of monetary system and things that happen and are evil and stuff like that. But I'm totally free of those because I understand that okay, you can live there, but you don't have to be the part of it anymore. And it's so relaxing because then you can just live your life the way that it should be lived, rather than running behind the money or watching the Netflix series and spending your life in a whatever you want. Like